Question. What is the primary purpose of the bunch object in scikit-learn? A. To efficiently store and access data points in a dataset. B. To perform complex mathematical operations on data. C. To manage and organize datasets with various attributes, including data, target, and metadata. D. To visualize data patterns and trends effectively. A. To efficiently store and access data points in a dataset. False.
While bunch can store data points, its primary purpose is not just efficient storage but also to manage and organize datasets as a whole, including target labels and metadata. B. To perform complex mathematical operations on data.
Not for performing mathematical operations. Scikit-learn provides separate functions and libraries for mathematical computations. C. To manage and organize datasets with various attributes, including data, target, and metadata. True. This is the correct answer. Bunch serves as a container for holding data, target labels, and descriptive metadata associated with a dataset. This structure simplifies data management and access in scikit-learn. D. To visualize data patterns and trends effectively. False. Data visualization is a separate process in data analysis, often handled by libraries like matplotlib or sklearn. While bunch can hold data for visualization, it doesn't perform visualization itself. C. 1. Dataset structure. Datasets are organized with features and labels. Datasets are typically structured with features-independent variables and labels-dependent variables. For example, in the iris dataset, features are measurements of sepal and petal length and width, and the label is the flower species. 2. Data loading. Importing data from files or databases. Data loading involves importing data from various sources, such as CSV files, databases, or online APIs. Scikit-learn provides functions like load iris for loading specific data sets. 3. Data pre-processing. Cleaning, transforming, and preparing data for model training. Data pre-processing is a crucial step before model training. It involves tasks like handling missing values, scaling features, and encoding categorical variables. This ensures the data is in a suitable format for machine learning algorithms. 4. Model training. Building and fitting a machine learning model to the data. Model training involves building a machine learning model based on the provided data. This typically involves selecting an appropriate algorithm and adjusting its parameters, hyperparameters, to optimize performance. 5. Data visualization. Creating visual representations of data for analysis. Data visualization allows for better understanding of data patterns and trends. Libraries like matplotlib and sklearn provide tools for creating various types of plots, such as histograms, scatter plots, and box plots. Python. From sklearn. Datasets. Import load iris. Iris load iris. Print iris.data. Print iris.target. Print iris.descript. 1. Load data. The load iris function loads the iris dataset into a bunch object called iris. 2. Access components. The iris.data attribute contains the feature data, iris.target holds the target labels, and iris.descript provides a description of the dataset. 1. Data loading and pre-processing. Load and organize data from different sources into a bunch object. Imagine you have a CSV file containing customer data for a marketing campaign. You can use Bunch to load this data, including customer demographics, purchase history, and campaign responses, for subsequent pre-processing and analysis. To model training, provide the Bunch object to training functions, including data, target, and metadata for model construction. After pre-processing your customer data, you can create a Bunch object containing features, demographics, purchase history, and the target variable campaign response. This Bunch can be fed directly into a machine learning algorithm for training a model to predict campaign success. 3. Data exploration. Access and analyze the data, target, and metadata within the Bunch object to gain insights. Before training a model, you might want to analyze the customer data stored in the Bunch object. This could involve examining the distribution of demographic features, identifying relationships between purchase history and campaign response, or understanding the overall characteristics of the data. What is the primary function of sklearn.utils.asFloatArray? A. To convert any input array to a number pi array of floats. B. To ensure all elements in the input array are numeric. C. To convert categorical data to numerical values. D. To standardize data by subtracting the mean and dividing by the standard deviation. E. All of the above. A. To convert any input array to a number pi array of floats. Correct. The function's first step is to convert the input array to a number pi array. It can handle various input types, including lists, tuples, pandas, data frames, etc., and transforms them into a number pi array with float data type. Number pi array, a fundamental data structure in Python for numerical computations, offering efficient storage and operations. For example, in a machine learning task, you might have a list of features represented as strings. Using sklearn.utils.asFloatArray will convert it into a number pi array of floats, making it suitable for processing by most scikit-learn algorithms. B. To ensure all elements in the input array are numeric. Correct. The function goes beyond converting to a number pi array. It ensures all elements are numeric by attempting to convert strings representing numbers to float values. This is crucial for many machine learning algorithms that require numeric data. Data types. The fundamental classification of data. Example: integers, floats, strings. Imagine having a list of features like 2.5, 3, 4.2. sklearn.utils.asFloatArray will convert the string 2.5 to a float 2.5, ensuring all elements are numeric. C. To convert categorical data to numerical values. Correct. The function can handle categorical data. It allows you to specify the encoding method, such as one-hot encoding, to convert categorical features into numerical representations. This is essential for machine learning algorithms that cannot directly process categorical data. Categorical data represented as categories or labels. Example: red, blue, green. If you have a dataset with a feature color with values like red, blue, green, sklearn.utils.asFloatArray can encode these values using one-hot encoding, resulting in binary columns for each color. Example: colored, color blue, color green. D. To standardize data by subtracting the mean and dividing by the standard deviation. Partially correct. While the function doesn't directly standardize data, it prepares it for standardization. By converting non-numeric elements to floats, it ensures that the data is suitable for standardization. The actual standardization would be a separate step. Data standardization, transforming data to have a zero mean and unit variance, often improving model performance. Before applying standardization, you would first use sklearn.utils.asFlowTarray to ensure your data is numeric. Then, you could use a method like standard scalar from scikit-learn to standardize the data. All of the above. Correct. As we discussed, the function performs all the functions mentioned in options A, B, C, and D, making E the correct answer. 1. Hot encoding, converting categorical features into binary vectors, where each category is represented by a separate column. In summary, sklearn.utils.asFlowTarray is a versatile pre-processing utility that ensures your data is ready for use with scikit-learn models. All of the above. Suppose you have a dataset with a feature called price containing values like 100, 200.5, 300. The price feature is currently a list of strings. Import numpy as np. From sklearn.utils import asFlowTarray. Price 100, 200.5, 300. Using asFlowTarray. Price numeric asFlowTarray price. Print price a numeric. Output 100, 200.5, 300. The asFlowTarray function converts the list of strings into a number pi array of floats, ensuring the price feature is ready for calculations and machine learning model training. What is the primary purpose of the sklearn.utils.assertleFinite function? A. To check if all elements in a dataset are within a specific range. B. To ensure all values in a dataset are finite, not nan or infinity. C. To identify missing values in a dataset. D. To perform basic data cleaning and normalization. B. To ensure all values in a dataset are finite, not nan or infinity. False. This statement describes the function's purpose to a certain extent, but it doesn't capture the entirety of it. Assertlefinite focuses on the finiteness of values, not their range. While a value within a specific range could be finite, a value outside that range can still be finite. B. To ensure all values in a dataset are finite, not nan or infinity. True. This choice accurately describes the primary purpose of assertlefinite. It aims to detect and raise an error if any value in the dataset is nan, not a number, or infinity. This ensures that all values are finite, a crucial requirement for stable and reliable machine learning models. B. To ensure all values in a dataset are finite, not nan or infinity. False. While assertlefinite can indirectly indicate missing values nans, it's not its primary purpose. The function's sole focus is on detecting and handling non-finite values. Missing values can be handled separately using techniques like imputation. B. To ensure all values in a dataset are finite, not nan or infinity. False. This option goes beyond the function's purpose. Assertlefinite only deals with identifying non-finite values. It doesn't perform cleaning or normalization. These tasks often require separate functions or techniques depending on the specific data cleaning requirements. B. To ensure all values in a dataset are finite, not nan or infinity. Nan, not a number. A special value representing an undefined or unrepresentable numeric result. It arises from operations like division by zero. In a dataset containing stock prices, a nan value might indicate that the stock was not traded on a particular day. This can be due to the market being closed or the stock being suspended from trading. The presence of NaN values can impact calculations and require handling. Infinity represents a value larger than any representable finite number. It can arise from operations like dividing a non-zero number by 0. In a dataset with calculations of user engagement, a value of infinity might occur if a user interacted with the platform an extremely high number of times within a short period. This could be a result of errors in data collection or unusual user behavior, requiring investigation. Data integrity. Ensuring that data is accurate, consistent, and reliable for analysis and modeling. Non-finite values can compromise data integrity. A dataset with customer details must ensure data integrity. Inaccurate or inconsistent data can lead to incorrect customer segmentation or targeting, resulting in ineffective marketing campaigns or service delivery. Machine learning model stability. Non-finite values can disrupt the training process and lead to unstable model predictions. A certain finite helps maintain model stability. In a model predicting housing prices, non-finite values in features like square footage or property age can lead to inaccurate predictions. Model stability is crucial for reliable predictions and consistent performance. Data pre-processing. The process of preparing data for machine learning, which often includes handling missing values, scaling features, and encoding categorical variables. When working with a dataset containing image data, pre-processing steps like resizing images to a uniform size are essential for training a model. This ensures consistency and prevents issues related to different image dimensions impacting model performance. Model training. The process of fitting a machine learning model to a dataset to learn patterns and relationships. Training a model to classify emails as spam or not spam requires a labeled dataset with emails categorized accordingly. The training process involves feeding this dataset to the model to learn the patterns that distinguish spam from non-spam emails. Model prediction. Using a trained machine learning model to make predictions on new, unseen data. Once a model for detecting fraudulent transactions is trained, it can be used to make predictions on real-time transactions occurring on an e-commerce platform. The model analyzes transaction data to identify potential fraudulent activities, enabling prompt action to prevent financial losses. Debugging. The process of identifying and resolving errors or unexpected behavior in code or models. If a model trained to predict customer churn fails to perform as expected, debugging involves analyzing the model's performance, identifying areas of inconsistency or errors, and correcting the model's behavior to ensure accurate churn predictions. Which of the following sklearn utils methods have been deprecated? A. sklearn.utils.check array. B. sklearn.utils.check random state. C. sklearn.utils.check consistent length. D. All of the above. This method was deprecated and is now located in the sklearn.utils.validation module. True. D. All of the above. This method was deprecated and is now located in the sklearn.utils.validation module. True. D. All of the above. This method was deprecated and is now located in the sklearn.utils.validation module. True. D. All of the above. All the methods listed in the options A, B, and C have been deprecated in sklearn. These methods are now part of the sklearn.utils.validation module. True. D. All of the above. D. All of the above. When a software feature is deprecated, it means it's no longer recommended for use and may be removed in future versions. These are helper functions in sklearn that aid in data pre-processing, validation, and other tasks. The new home for the deprecated sklearn utilities methods, providing a centralized location for data validation functions. Ensuring that data inputs are formatted correctly, with consistent types and dimensions. Checking for missing values, outliers, and other data quality issues before training models. Controlling the reproducibility of machine learning models by setting random seeds. 1, 2, 3, 4, 5, 6, 7, 8, 9. Check array data, ensure 2D true. The check array method would ensure the input data is a two-dimensional array matrix by checking its shape and data type. If it's not, it would raise an error or attempt to reshape the array based on the ensure 2D parameter. Data validation. What does the estimator HTML repair function in sklearn's utils module do? A returns a string representation of the estimator's parameters. B generates a HTML representation of the estimator's attributes. C provides a summary of the estimator's performance metrics. D all of the above. Partially correct. The estimator HTML repair function does generate a string representation, but it's not just for parameters. It includes attributes and performance metrics as well. Estimator. Partially correct. This is part of what the function does. It generates a HTML representation, but it also includes parameters and performance metrics. Estimator. Partially correct. The estimator HTML repair function includes performance metrics in its HTML representation, but it also provides information about the estimator's parameters and attributes. Estimator. Correct. The estimator HTML repair function does all of the above. It generates a HTML representation that encompasses the estimator's parameters, attributes, and performance metrics. Estimator. D all of the above. An estimator is a machine learning algorithm that learns from data and makes predictions. Examples include linear regression, logistic regression, and decision trees. Let's say we have a dataset of house prices with features like size, number of bedrooms, location, etc. A linear regression estimator can be trained on this data to learn the relationship between these features and house prices. Once trained, it can predict the price of a new house given its features. Predicting customer churn in a telecom company. Classifying emails as spam or not spam. Forecasting sales for a retail store. This function takes an estimator as input and generates a HTML representation of its parameters, attributes, and a summary of its performance. Let's assume we have a trained logistic regression estimator. Using estimator HTML repair, we can get a HTML output that displays information like its coefficients parameters, intercept, number of iterations it took to converge attributes, and its accuracy score on a test dataset performance metric. Debugging a machine learning model. Generating documentation for a custom estimator. Presenting model insights in an interactive report. This module provides utility functions that are helpful for working with machine learning models in sklearn. The utils module also includes functions like safe indexing, check array, and check random state, which are used for data pre-processing and ensuring consistency in the data provided to the estimators. Preparing data for training and testing machine learning models. Validating model input and output. Implementing advanced data analysis techniques. View the inner workings of your estimator for troubleshooting and understanding its configuration. If you are facing issues with a machine learning model's performance, using estimator HTML repair can help you identify if any parameters are set incorrectly, if any features are missing, or if there are issues with the training data itself. Estimator. Generate clear and concise HTML documentation for your custom estimators. When creating your own machine learning models, you can use estimator HTML repair to provide a comprehensive and user-friendly documentation for others who want to use or understand your estimator. Which of the following statements is true about sklearn.utils.genbatches? A. It is a function that splits a dataset into batches of a specified size. B. It is a class that handles the batching process for a dataset. C. It is used to generate batches of data for training and testing. D. It is a class that handles the splitting process for a dataset. E. All of the above. Explanation: the statement is correct. sklearn.utils.genbatches is indeed a function that divides a dataset into smaller, equally sized batches. This functionality is crucial for training machine learning models efficiently, particularly when dealing with large data sets. Explanation: the statement is incorrect. sklearn.utils.genbatches is not a class but a function. It directly performs the task of batching without relying on class instantiation. Explanation: the statement is correct. sklearn.utils.genbatches is primarily used to generate batches of data for training and testing purposes. This helps optimize the training process by managing memory usage and improving training efficiency. Explanation: the statement is incorrect. While it does involve splitting a dataset, sklearn.utils.genbatches is a function, not a class. The splitting process is handled directly within the function. Explanation: the statement is correct. All of the previous statements accurately describe the functionality of sklearn.utils.genbatches. It's a function that splits data into batches, primarily used for training and testing, making it a versatile tool for dataset management. Explanation: all of the above. Batching. Batching in machine learning involves dividing a dataset into smaller, manageable groups called batches. This approach is commonly used during training and testing phases to enhance memory efficiency and reduce computational overhead.
One. Batching, training and testing. In machine learning, training involves feeding a model with labeled data to learn patterns and relationships. Testing, on the other hand, evaluates the model's performance on unseen data to assess its generalization ability. Batching plays a vital role in both phases, optimizing the learning and evaluation processes. 2. Training and testing. Training deep learning models. Deep learning models often require massive datasets for training. Batching is crucial in this context, as it allows the model to process data in smaller chunks, reducing memory requirements and speeding up training times. 1. Training deep learning models. Large-scale machine learning. When dealing with vast datasets, batching becomes essential for handling data efficiently. It prevents memory overload and allows for training models within reasonable timeframes, making large-scale machine learning projects more feasible. 2. Large-scale machine learning. Python. From sklearn, utils import gen batches. Data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Batch size 3. For batch in gen batches data. Batch size. Print batch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Code example. Data splitting. Data splitting is the process of dividing a dataset into distinct subsets for training and testing. This is essential for evaluating the model's performance on unseen data. 1. Data splitting. Dataset management. Dataset management encompasses various techniques and strategies for organizing, storing, and accessing data efficiently. Batching plays a vital role in dataset management, particularly for large datasets. 2. Dataset management. Model training. Model training involves feeding data to a machine learning model to learn patterns and relationships. Batching is frequently employed during training to optimize memory usage and improve training speed. 3. Model training. What is the primary function of sklearn, utils, genuine slices in machine learning? A. To generate evenly sized slices of data for cross-validation. B. To perform feature scaling and normalization. C. To create and manage pipelines for data preprocessing. D. To train machine learning models using a predefined set of algorithms. True. This is the correct answer. Genuine slices is designed to divide a dataset into equally sized chunks, often for the purpose of cross-validation. This ensures a balanced representation of data in each fold of the cross-validation process, leading to more reliable model evaluation. False. This is incorrect. Feature scaling and normalization are handled by other functions within scikit-learn, such as standard scaler and min-max scaler. False. This is incorrect. Data preprocessing pipelines are created using pipeline in scikit-learn. Genuine slices doesn't directly participate in pipeline creation. False. This is incorrect. Training machine learning models is the task of specific algorithms like logistic regression, decision tree classifier, or random forest regressor, not genuine slices. A. To generate evenly sized slices of data for cross-validation. Cross-validation, data splitting, model evaluation, data slicing, k-fold cross-validation. Stratified k-fold cross-validation. Leave one out cross-validation. The function genuine slices divides a dataset into evenly sized chunks or slices to ensure that each fold in a cross-validation process has an equal amount of data, promoting fair and unbiased model evaluation. From sklearn, utils import genuine slices. Data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N splits 5. Slices genuine slices len data. N splits. For slice idx in slices. Printf slice idx. Data slice idx. Slice 0, 2, 1, 2. Slice 2. 4, 3, 4. Slice 4, 6, 5, 6. Slice 6, 8, 7, 8. Slice 8, 10, 9, 10. What is the purpose of the indexable utility in scikit-learn? A. Ensures data structures are suitable for scikit-learn's estimators. B. Converts data to a NumPy array format. C. Handles missing values in the data. D. All of the above. Scikit-learn estimators often require data in specific formats like NumPy arrays or pandas. Data frames. The indexable utility ensures your data conforms to these requirements, preventing unexpected errors. True. A. Ensures data structures are suitable for scikit-learn's estimators. NumPy arrays are the preferred data format for many scikit-learn algorithms. The indexable utility can efficiently convert various data structures to NumPy arrays, enhancing computational efficiency. True. B. Converts data to a NumPy array format. Missing values can disrupt machine learning algorithms. The indexable utility effectively handles missing values, either by removing them or imputing them with appropriate values. True. C. Handles missing values in the data. All the options are correct, so the answer is D. All of the above. True. D. All of the above. D. All of the above. Before feeding data to an estimator, ensuring it's in a suitable format and handling missing values. Simplifying model training and prediction by ensuring consistent data structures. Facilitating analysis by providing a consistent way to access and manipulate your data. NumPy arrays, pandas data frames, lists, dictionaries. Linear regression, decision trees, support vector machines, etc. Imputation, removal. What is the primary function of the sklearn, utils, murmurish 332 function in scikit-learn? A. To perform data normalization and scaling for machine learning models. B. To calculate the inverse of a matrix for linear algebra operations. C. To generate a 32-bit hash value for data, often used for efficient data indexing and hashing. D. To perform dimensionality reduction techniques like PCA principal component analysis. C. To generate a 32-bit hash value for data, often used for efficient data indexing and hashing. The sklearn, utils, murmurish 332 function implements the murmur-3 algorithm, which is a non-cryptographic hash function known for its speed and efficiency. It takes a string or byte sequence as input and produces a 32-bit hash value. This hash value is often used for indexing data structures, efficiently mapping data to unique identifiers, and performing hash-based comparisons. Data normalization and scaling are typically handled by functions like standard scaler, min-max scaler, or robust scaler in scikit-learn, not murmurish 332. Matrix inversion is a linear algebra operation usually performed by functions like NumPy, lena-lg.inv. Murmurish 332 doesn't deal with matrix operations. Dimensionality reduction techniques like PCA are implemented by functions like sklearn, decomposition, PCA. Murmurish 332 is not related to dimensionality reduction. Hash-based data structures implementing hash tables, hash sets, and other data structures where efficient key lookups are crucial. Data indexing quickly finding data points based on their unique hash values. Hash-based comparisons efficiently comparing data points by comparing their hash values. Hash functions algorithms that map data of arbitrary size to a fixed size output the hash value. Hash tables data structures that use hash functions to efficiently store and retrieve data. Data indexing creating efficient ways to access and retrieve specific data points in large datasets. Hashing algorithms different methods for calculating hash values, such as MD5, SHA-256, and murmur hash. What is the primary purpose of the sklearn, utils, resample function in scikit-learn? A. To randomly select a subset of samples from a dataset. B. To create balanced datasets by oversampling or undersampling minority classes. C. To perform feature scaling or normalization. D. All of the above. A. To randomly select a subset of samples from a dataset. True. The sklearn, utils, resample function can be used to randomly select a subset of samples. This is achieved by setting the n samples parameter to the desired number of samples and using replace false to prevent duplicate samples. B. To create balanced datasets by oversampling or undersampling minority classes. True. It can be used to create balanced datasets by oversampling or undersampling minority classes. For oversampling, use replace true to duplicate samples from the minority class. For undersampling, use replace false and adjust the n samples parameter. C. To perform feature scaling or normalization. False. Feature scaling and normalization are separate processes in data preprocessing and are not the primary purpose of sklearn, utils, resample. There are dedicated functions in scikit-learn for these tasks, such as standard scaler and min-max scaler. D. All of the above. True. All the statements in A, B, and C are correct. Therefore, D is the most accurate answer as it encompasses all the functionalities provided by sklearn, utils, resample. D. All of the above. Resampling techniques. Resampling techniques are employed to alter the distribution of data in a dataset, often to address issues related to class imbalance or to optimize model performance. Some common techniques include random subsampling. This involves randomly selecting a subset of samples from the original dataset, effectively reducing its size. This can be useful for reducing computational overhead or for creating a more manageable dataset. For testing purposes, oversampling. In oversampling, the minority class is artificially replicated or augmented to increase its representation in the dataset. This can help to improve the model's ability to learn from and predict on the minority class. Undersampling. Undersampling works by reducing the size of the majority class, aiming to create a more balanced dataset by eliminating samples from the majority class. This can be beneficial for improving model efficiency and reducing the risk of overfitting to the majority class. Imbalanced datasets. Imbalanced datasets are those where the distribution of classes is highly uneven, leading to biased model predictions. In such datasets, the majority class dominates, while the minority class is underrepresented. Models trained on imbalanced datasets often exhibit poor performance on the minority class, making it crucial to address this imbalance using techniques like resampling. Data augmentation. Data augmentation techniques are used to artificially increase the size of a dataset by creating new samples from existing ones. This can be beneficial for preventing overfitting, improving model generalization, and addressing data scarcity. These techniques are often employed in conjunction with resampling to enhance the effectiveness of data balancing. Model performance metrics. Evaluating model performance on imbalanced datasets requires careful consideration of metrics beyond accuracy. Metrics like precision, recall, F1 score, and AUC provide a more comprehensive evaluation of the model's ability to predict the minority class accurately. These metrics allow us to assess the trade-off between correctly identifying positive instances, precision, and minimizing false negatives. Recall, which are particularly important in scenarios involving imbalanced datasets. From sklearn, utils import resample, x resampled, year sampled resample x, y, original data, replace true, sample with replacement for oversampling. N samples 1000 number of samples to generate. This code snippet demonstrates how to use resample for oversampling. It takes the original feature matrix X and target vector Y as input. By setting replace true, it indicates that samples can be duplicated to increase the representation of the minority class. The N samples parameter specifies the desired size of the resampled dataset. The function returns the resampled feature matrix X resampled and the corresponding target vector. Year sampled. Example. Let's assume we have a dataset where the majority class has 900 samples and the minority class has 100 samples. Using resample with n samples 1000 and replace true would oversample the minority class to create a balanced dataset with 500 samples from each class. This balanced dataset could then be used to train a more robust model. In scikit-learn's safe indexing, what's the primary role of the indices argument? It defines the specific data points to be selected from the input array. It specifies the column indices to be extracted from the input array. It indicates the row indices to be selected from the input array. All of the above. True. This is correct. The indices argument in safe indexing is used to select specific data points from the input array. It acts as a filter, identifying which elements should be included in the resulting array. The indices argument in safe indexing plays a crucial role in specifying which data points to select from the input array. It can represent row indices, column indices, or even a combination of both, making it a versatile tool for selecting specific data slices. True. This is also correct. The indices argument can be used to specify column indices, allowing you to extract specific columns from the input array. The indices argument in safe indexing plays a crucial role in specifying which data points to select from the input array. It can represent row indices, column indices, or even a combination of both, making it a versatile tool for selecting specific data slices. True. This is also correct. The indices argument can be used to select rows from the input array, enabling you to isolate particular rows based on their indices. The indices argument in safe indexing plays a crucial role in specifying which data points to select from the input array. It can represent row indices, column indices, or even a combination of both, making it a versatile tool for selecting specific data slices. True. This is the most comprehensive answer. The indices argument can be used to select data points based on row indices, column indices, or a combination of both. It offers flexibility in data selection. The indices argument in safe indexing plays a crucial role in specifying which data points to select from the input array. It can represent row indices, column indices, or even a combination of both, making it a versatile tool for selecting specific data slices. All of the above. Array indexing is the process of accessing specific elements within arrays based on their positions. It allows you to retrieve, modify, or manipulate individual elements or groups of elements within an array. Consider an array data 10, 20, 30, 40, 50. To access the second element, you would use data 1, which would return 20. Data manipulation involves modifying and transforming data for analysis and processing. It encompasses various techniques like filtering, sorting, merging, and reshaping data to make it suitable for specific tasks. Suppose you have a dataset of student grades. You could manipulate the data by filtering students with grades above 90. Sorting them by grade, or calculating the average grade for each subject. Scikit-learn is a powerful Python library for machine learning. It provides a wide range of tools for data analysis, pre-processing, model building, and evaluation, making it a popular choice for both beginners and experienced machine learning practitioners. You could use scikit-learn to train a machine learning model to predict house prices based on features like location, size, and number of bedrooms. Data preprocessing is an essential step in machine learning. It prepares data for models by addressing issues like missing values, inconsistent data formats, and feature scaling. This step helps improve the accuracy and performance of machine learning models. Before training a model to predict customer churn, you might need to preprocess the data by filling in missing values for customer demographics, converting categorical features into numerical representations, and scaling feature values. Safe indexing in scikit-learn is a mechanism that ensures the selected indices are valid and within the bounds of the input array. It prevents potential errors that can arise from accessing elements outside the array's boundaries. Imagine you have a dataset with 100 rows. If you use safe indexing to select rows with indices from 1 to 105, the function would handle the out-of-bounds indices gracefully, preventing errors and ensuring data integrity. What is the primary role of sklearn, utils, safesca function in scikit-learn? A. Calculates the square of a number, handling potential overflow issues. B. Normalizes data by scaling it to a specific range. C. Performs a safe square operation, preventing potential numerical instability. D. All of the above. While safesca does square a number, its primary focus isn't just handling overflow. It addresses a broader range of numerical stability issues. False. Scaling data falls under the umbrella of data preprocessing and can be part of a broader strategy to improve numerical stability, but it's not the core function of safesca. False. This aligns with the primary role of safesca. By preventing numerical instability, it ensures reliable and accurate results, especially in scenarios involving large numbers. True. As safesca directly tackles numerical instability, encompassing overflow handling, and normalization can be indirect strategies. This option is correct. True. D. All of the above. 1. Numerical stability refers to the robustness of calculations in the face of potential errors due to limited precision. In computers, especially when dealing with very large or very small numbers. 2. Overflow and underflow. Overflow happens when a calculation produces a result larger than the maximum representable value, leading to incorrect results. Underflow occurs when a result is smaller than the minimum representable value, often causing it to become zero. 3. Scaling. A technique used to adjust the range of data, often by dividing by a factor or subtracting the mean. It can help prevent overflow or underflow by reducing the magnitude of values. 4. Clamping. A method to limit the range of values, restricting them to a specific interval. If a value exceeds the limit, it's clamped to the maximum or minimum value of the interval, preventing extreme values. 1. Machine learning algorithms. Many machine learning algorithms are sensitive to numerical instability, and safesca can help ensure their reliable performance by preventing errors caused by large or small values. 2. Data preprocessing. During data preprocessing, scaling techniques can be employed to normalize the range of features, which can indirectly contribute to numerical stability. While not directly used in scaling, safesca can be applied in other preprocessing steps. 3. Numerical computations. In general scientific computing and numerical analysis, SafeSCA can be valuable in scenarios where precise and reliable square calculations are crucial, especially when handling potentially large or small numbers. 1e100. 1e100. Consider squaring numbers with extremely large or small magnitudes like 1e101 followed by 100 zeros and 1e-101 divided by 100 zeros. Without SafeSCA, direct squaring could lead to overflow or underflow, resulting in inaccurate results. SafeSCA would handle these scenarios by applying appropriate scaling or clamping to keep A results within a safe range. Which function in sklearn, utils shuffle randomly shuffles the rows of a dataset? A. Shuffle. B. Random shuffle. C. Shuffle data. D. All the above. Correct. The shuffle function in sklearn, utils is used to randomly shuffle rows of a dataset. It takes the dataset as input and returns a shuffled version. It can also take an optional random state parameter to control the randomness and ensure reproducibility. A. Shuffle. Correct. Random shuffle is also a function in sklearn, utils that shuffles the rows of a dataset randomly. It's a synonym for the shuffle function and accomplishes the same functionality. B. Random shuffle. Correct. Shuffle data is yet another function in sklearn, utils that shuffles data. This function is also synonymous with the shuffle function. It offers the same shuffling capabilities and takes the same parameters. C. Shuffle data. Correct. All three functions mentioned above, shuffle, random shuffle, and shuffle data, are valid functions in sklearn, utils and have the same purpose of randomly shuffling rows in a dataset. D. All the above. D. All the above. Randomization is a fundamental concept in machine learning and statistics. It involves introducing randomness into processes to ensure unbiased results and to avoid overfitting. It's essential for creating robust models and making reliable predictions. 1. Randomization. Data preprocessing is a crucial step in machine learning. It involves transforming raw data into a format suitable for training models. This may involve cleaning, transforming, scaling, or shuffling data. 2. Data preprocessing. sklearn, utils is a module in the scikit-learn library containing various utility functions for working with data. It includes functions for shuffling, splitting, and other data preparation tasks. 3. sklearn, utils. Dataset shuffling is a common data preprocessing technique used to randomize the order of data points in a dataset. It helps to avoid bias, enhance model generalization, and ensure fairness in training. 4. Dataset shuffling. Randomization plays a crucial role in building machine learning models. For example, in the training process, randomizing data samples ensures that the model learns from a diverse set of data points, reducing the chances of overfitting. 1. Randomization in machine learning models. Cross-validation is a technique used to evaluate the performance of a model. Before performing cross-validation, data is shuffled to create independent training and testing sets, allowing for an unbiased evaluation of the model's performance. 2. Preparing data for cross-validation. In applications where fairness is crucial, shuffling ensures that data samples are drawn randomly, minimizing biases and ensuring that all segments of the population are represented fairly in data. 3. Ensuring fairness in data sampling. When training machine learning models, it's important to prevent biases in the training data. Shuffling helps to randomize the order of data points, reducing the chances of biases influencing the model's training. 4. Preventing bias in training data. In deep learning, models are often trained using batches of data. Shuffling helps to create diverse batches, exposing the model to different data patterns and improving its learning process. 5. Generating diverse training batches. Let's assume we have a dataset with 10 data points represented as a list. Data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From sklearn, utils import shuffle data print shuffle data. The shuffle function will randomly shuffle the order of elements in the list, resulting in a different order each time it is executed. Which of the following functions is used to split a dataset into training and testing sets in sklearn? A. Train test split. B. Crosswalk score. C. K-fold. D. All of the above. This function is used to split data into training and testing sets, which is a fundamental step in model building and evaluation. It allows you to train a model on a portion of the data and then assess its performance on unseen data. This function performs cross-validation, a technique to evaluate a model's performance by splitting the data into multiple folds and iteratively using different folds for training and testing. This helps assess how well the model generalizes to unseen data. K-fold is a specific cross-validation strategy where the data is divided into K-folds. Each fold is used for testing once, while the remaining folds are used for training. This helps provide a more robust evaluation of the model's performance. All three functions contribute to splitting and evaluating data in sklearn. Train test split is for the initial split. Crosswalk score provides a more comprehensive evaluation, and K-fold is a specific cross-validation technique. D. All of the above. Dividing a dataset into training data for model building and testing data for model evaluation. BRBR example: building a model to predict house prices using historical data, with 80 for training and 20 for testing. A technique to evaluate a model's performance by splitting the data into multiple folds, using different folds for training and testing in each iteration. BRBR example: evaluating a loan risk prediction model using 5-fold cross-validation, ensuring a more robust assessment. A specific cross-validation technique where the dataset is divided into K-folds, with each fold used for testing once while the rest are used for training. BRBR example: implementing a 5-fold K-fold to assess a spam detection model's performance. 1. Model training and evaluation: splitting data for training and testing a machine learning model for tasks such as image classification, sentiment analysis, or fraud detection. BRBR 2. Hyperparameter tuning using cross-validation to optimize model hyperparameters to find the best configuration for a given dataset. BRBR 3. Robust model assessment employing cross-validation to ensure that a model generalizes well to unseen data and doesn't overfit to the training data. Which of the following statements accurately describes the checkexe function in scikit-learn's utils? Module A. It checks if the input data is a pandas data frame and converts it to a NumPy array. B. It ensures that the input data is in a suitable format for machine learning algorithms, primarily checking for the presence of missing values and data types. C. It performs feature scaling on the input data, ensuring that all features have similar scales. D. It checks for any inconsistencies in the shape and dimensions of the input data, raising an error if there are issues. E. All of the above. This is partially correct. Checkexe can handle pandas data frames and convert them to NumPy arrays. But it also performs other checks beyond just data type conversion. 1. Data type conversion. It can handle pandas data frames and convert them to NumPy arrays, which are the preferred data structures for most machine learning algorithms. This is partially correct. Checkexe does ensure data is in a suitable format for machine learning. But it also checks for more than just missing values and data types. It checks for shape and dimension consistency and handles errors as well. 2. Data format validation. It verifies that the input data is in a suitable format, including checking for missing values, data types, and ensuring consistent dimensions. This is incorrect. Feature scaling is a separate preprocessing step and is not handled by checkexe. 3. Feature scaling. Scaling features to a similar range can improve the performance of many machine learning algorithms. This is partially correct. Checkexe does verify shape and dimension consistency, but it also handles other aspects like data type conversion and missing value checks. 3. Shape and dimension consistency. It checks if the input data has the expected shape and dimensions, ensuring that the features and targets align correctly. This is correct. Checkexe performs data type conversion, data format validation, shape and dimension checks, and error handling to ensure the input data is suitable for machine learning. 1. Data type conversion. It can handle pandas data frames and convert them to NumPy arrays, which are the preferred data structures for most machine learning algorithms. 2. Data format validation. It verifies that the input data is in a suitable format, including checking for missing values, data types, and ensuring consistent dimensions. 3. Shape and dimension consistency. It checks if the input data has the expected shape and dimensions, ensuring that the features and targets align correctly. 4. Error handling. It raises an error if any of the above checks fail, preventing potential issues that could disrupt the model training process. E. All of the above. Understanding data types is crucial for choosing appropriate machine learning algorithms. For example, linear regression is suitable for numerical data, while decision trees can handle both numerical and categorical data. Suppose you have a dataset with features like age numerical, gender categorical, and income numerical. You can use a decision tree algorithm to model the relationship between these features and a target variable like loan approval status. Data cleaning is essential for removing errors and inconsistencies from your dataset. It involves handling missing values, outliers, and duplicate records. Imagine you have a dataset of house prices with missing values for some features like square footage. You can handle missing values using techniques like mean imputation or dropping rows with missing data. Scaling features to a similar range can improve the performance of many algorithms. particularly distance-based algorithms like k-nearest neighbors KNN and support vector machines SVMs. Consider a dataset with features like age ranging from 18 to 80 and income ranging from 10,000 to 1 million. Scaling these features to a common range e.g. 0 to 1 can prevent features with larger ranges from dominating the distance calculations. Dimensionality reduction techniques can help reduce the number of features in your dataset, which can improve model performance and reduce computational complexity. In an image dataset with thousands of pixels, dimensionality reduction techniques like principal component analysis (PCA) can be used to extract the most important features, leading to a smaller and more manageable dataset. Evaluating your model's performance on unseen data is crucial for determining its effectiveness in generalizability. Common metrics include accuracy, precision, recall, and F1 score. After training the spam classifier, you can evaluate its performance on a separate set of emails test set to see how accurately it can classify new emails as spam or not spam. Hyperparameter tuning involves finding the optimal values for model parameters that are not learned from the data. This can significantly improve model performance. For a support vector machine SVM model, you can tune hyperparameters like the regularization parameter C and the kernel type to find the best combination for your data. Scikit-learn provides a wide range of machine learning models estimators for tasks like classification, regression, clustering, and more. For image classification, you can use the logistic regression estimator from scikit-learn to train a model that can classify images into different categories. What are the core functionalities provided by the sklearn, utils, checkarray function? Choose the most comprehensive option. A. Ensures data is 2D array, converts lists tuples, and handles sparse matrices. B. Handles data type conversions, checks for missing values, and enforces D-type. C. Ensures data is a NumPy array, handles data scaling, and performs dimensionality reduction. D. All of the above. True. This statement accurately reflects some of the core functionalities of checkarray. It ensures data is a 2D array, which is a fundamental requirement for many machine learning algorithms. It can also convert lists and tuples into arrays, making it adaptable to different input formats. Additionally, it supports various sparse matrix formats, crucial for handling large datasets with a high percentage of zeros. True. Checkarray is also responsible for handling data type conversions. This means it can convert data to the desired data type D-type, such as floats or integers. Moreover, it identifies missing values, potentially imputing them or raising an error depending on your settings. By enforcing a specific data type, it ensures consistency in your data. False. This statement is partially correct but incomplete. Checkarray indeed ensures data is a NumPy array, facilitating efficient computations. However, data scaling and dimensionality reduction are separate pre-processing steps that are typically performed after ensuring data consistency using checkarray. True. This option is correct as checkarray encompasses all the functionalities mentioned in options A and B. It ensures data is a 2D NumPy array, handles various input formats, performs data type conversions, checks for missing values, and enforces a specific data type. It is a versatile tool for ensuring data consistency before feeding it into machine learning models. D. All of the above. NumPy arrays are the foundation of numerical computing in Python. They provide efficient storage and manipulation of numerical data. The checkarray function often converts data to NumPy arrays to ensure efficient processing in scikit-learn models. Imagine analyzing a dataset of house prices. You would store this data in a NumPy array to perform calculations like mean price, standard deviation, or correlations efficiently. Sparse matrices are used to represent data with a large number of zeros. They offer efficient storage and computation for datasets with many sparse elements. The checkarray function can handle various sparse matrix formats, such as CSR or COO matrices. Consider a recommendation system for movies. You would likely have a sparse matrix where rows represent users and columns represent movies. The matrix would contain ratings or interactions for movies that users have seen, while unseen movies would have zero values. This type of data is ideal for representing with sparse matrices. Data types D-type specify the kind of data you are working with. Common data types include integers, floats, strings, and booleans. Checkarray can enforce a specific data type to maintain consistency in your dataset. In a customer dataset, you might have an age column containing integer values. You could use checkarray to ensure that this column only contains integer data, preventing potential issues in calculations or model training. Data scaling involves transforming data to a specific range, such as 0 to 1. This is often used in machine learning to improve model performance. While checkarray doesn't perform scaling, it is typically a preprocessing step performed after ensuring data consistency using checkarray. Imagine you have a dataset with features representing income and age. Income values might range from a few thousand to millions, while age is in a much smaller range. Scaling these features to a similar range can improve the performance of certain machine learning algorithms. Dimensionality reduction techniques aim to reduce the number of features in a dataset. They are used to improve model performance by reducing noise and redundancy in the data. Dimensionality reduction is also performed after ensuring data consistency using checkarray. Consider a dataset with hundreds of features describing a product's characteristics. You could use dimensionality reduction techniques, such as principal component analysis (PCA), to extract the most important features and reduce the number of dimensions, making the dataset more manageable and potentially improving model performance. What is the primary purpose of sklearn, utils, checkscaler in machine learning? A. To check if a given input is a scalar value single number. B. To verify if a variable is a valid scalar type int, float, etc. C. To ensure a scalar value falls within a specified range. D. All of the above. This is correct. The checkscaler function ensures that the input is a single value and not an array or list for example. It would identify that the input 5 is a scalar, while 5 is not. True. This is also correct. Checkscaler verifies that the input type is a valid scalar type. It accepts integers int, floating point numbers float, and other numeric types. True. This is correct. The checkscaler function allows you to specify a minimum and maximum value. It will ensure that the provided scalar value falls within that range. For example, if you specify a range of 0, 1, it will reject values outside that range, like -2 or 1.5. True. This is the correct answer. Checkscaler is designed for data integrity and combines all three checks: scalar check, type check, and range check. True. D. All of the above. Scalar values. Single numbers representing individual data points, e.g., 5, 3.14, -2. Imagine you are building a model to predict house prices based on square footage. The square footage of a house is a scalar value. Data integrity. Ensuring data is accurate, consistent, and reliable for model training. This means avoiding missing values, inconsistent data types, or unrealistic values. In a dataset of customer ages, a value of 150 years old would be unrealistic and could negatively impact the model's accuracy. Checkscaler can be used to catch such errors. Hyperparameters. Parameters that control the learning process of a model, e.g., learning rate, regularization strength. They are often set before training. When training a machine learning model, you might use checkscaler to ensure the learning rate is a valid scalar within a reasonable range, e.g., between 0.001 and 0.1. Custom estimators. User-defined machine learning components, often tailored to specific tasks or data structures. Let's say you are creating a custom component to predict customer churn. You might use checkscaler to ensure that certain inputs, e.g., customer tenure, are valid scalar values. What is the purpose of the sklearn, utils, check consistent length function in scikit-learn? To check if the input data is consistent with the model's expected input length. To ensure that all input arrays have the same length. To check for missing values in the input data. To ensure that the input data is properly scaled. The correct answer is B. To ensure that all input arrays have the same length. The check consistent length function is a utility function within scikit-learn designed to ensure that all input arrays provided to machine learning algorithms have the same number of samples rows. This is crucial for maintaining consistency and preventing errors during model training and prediction. Choice B is correct because the function ensures that all input arrays have the same length. This is crucial for model training and prediction as it prevents errors caused by inconsistent data. Dimensions. The other choices are incorrect. A is incorrect because the function doesn't check if data is consistent with the expected input. Length. C is incorrect because the function doesn't check for missing values. D is incorrect because the function doesn't ensure data scaling. Let's say you have two arrays representing features: ages of customers and income of customers. If age has 100 samples and income has 95 samples, the model won't work properly. Check consistent length will raise an error. Preventing this issue. Imagine you are building a model to predict customer churn using features like age, income, and purchase history. If the number of samples in each feature array doesn't match, the model will be unable to learn effectively. Check consistent length ensures that all data aligns, preventing mismatches and ensuring data integrity for your model. If you have data for age, income, and purchase history, each feature array should have the same number of samples. If one array has 100 samples, and the other has 90 samples, The model won't train properly. Check consistent length guarantees that all features have the same number of samples. Data integrity. Data integrity refers to the accuracy, completeness, and consistency of data. Check consistent length contributes to data integrity by ensuring all input arrays have the same number of samples. Data preprocessing. Data preprocessing involves preparing data for machine learning algorithms. Check consistent length is a preprocessing step that helps to ensure data is ready for modeling. Machine learning pipelines. Machine learning pipelines automate the process of data preprocessing, model training, and prediction. Check consistent length can be incorporated into a pipeline to ensure data consistency throughout a process. Which of the following statements accurately describes the purpose and functionality of sklearn, utils, check random state in scikit-learn? A. Ensures consistent random number generation across multiple runs of the same algorithm, helping to reproduce results. B. Randomly selects a subset of features from a dataset for model training, leading to more efficient model building. C. Generates random numbers following a specific probability distribution, such as normal or uniform distribution. D. All of the above. Correct. This statement accurately describes how check-random state works when you provide an integer seed. The same seed will always generate the same sequence of random numbers, ensuring consistent behavior across runs. 1. Integer generates a LT font color co 0000FF quote GT LTB GT numpy. Random state LTB GT LT font GT instance, with a seed initialized to the provided integer. This ensures consistent random number generation across multiple runs with the same integer. Correct. This describes a common technique called feature selection, often used in model building for efficiency. However, check-random state doesn't directly perform feature selection. It's a tool for managing random number generation, which might be used within feature selection algorithms. 1. Integer generates a LT font color co 0000FF quote GT LTB GT numpy. Random state LTB GT LT font GT instance, with a seed initialized to the provided integer. This ensures consistent random number generation across multiple runs with the same integer. Correct. The numpy, random state object returned by check-random state is used to generate random numbers. It provides methods like rand uniform distribution, randn normal distribution, and others to generate numbers following specific distributions. 3. Numpy, random state directly returns the provided LT font color co 0000FF quote GT LTB GT numpy. Random state LTB GT LT font GT instance, allowing you to use your own random number generator. Correct. All three statements accurately describe the functionality of check-random state in one way or another. It ensures consistent random number generation, potentially used in feature selection, and provides a tool for generating random numbers according to specific distributions. LT font color co 009900 quotient D. All of the above. LT font GT. D. All of the above. Random number generation. The process of creating sequences of numbers that appear random. In computer science, these are often generated using algorithms, making them pseudo-random. Simulation in simulations, e.g., modeling the spread of a disease or simulating stock market behavior. Random numbers are used to represent uncertainty and variability. Seed. An initial value used to start a random number generator. The same seed will always produce the same sequence of random numbers. Debugging. Setting a specific seed in your code can help you consistently reproduce errors or unexpected behavior, making debugging easier. Pseudo-randomness. Numbers generated by algorithms that appear random but are deterministic. The same seed will always produce the same sequence. Cryptography. Pseudo-random number generators are used in cryptography, but strong algorithms are essential to ensure their security. Reproducibility. The ability to repeat an experiment or calculation and get the same results. It's crucial for scientific research and software development. Machine learning. Reproducibility allows researchers to validate their findings and ensures that the behavior of algorithms is consistent across different runs. Let's say you are training a model to predict house prices. The model uses a random number generator for internal operations like splitting data into training and validation sets. Import NumPy is NP. From sklearn, utils import check random state. Set a seed for reproducibility. Random state check random state 42. Generate random numbers, e.g., for data splitting. Random numbers random state, rand10. Print random numbers. This code sets a seed of 42 using check random state. Every time you run this code with the same seed, you'll get the same sequence of random numbers. This is essential for reproducing the model's behavior and ensuring consistent results during experimentation. Consider a scikit-learn estimator like logistic regression. How can you check if it has been fitted to data? Using sklearn, utils, validation, check is fitted. A. Check is fitted estimator, attributes score. B. Check is fitted estimator, attributes intercept. C. Check is fitted estimator. D. All of the above. Correct check is fitted verifies if an estimator has been fitted to data. It checks for specific attributes like core, intercept, etc. that are typically set during the fitting process. Providing the core attribute in the attributes argument allows the function to check if this attribute is present, ensuring the estimator has been fitted. Correct similar to choice A. Specifying the intercept attribute in the attributes argument allows check is fitted to verify its presence, confirming that the estimator has been fitted to data. Correct check is fitted can be used without any specific attributes. In this case, it checks for default attributes typically associated with fitted estimators, such as core, intercept, or others depending on the estimator type. This ensures the estimator has been fitted. Correct as all the above choices are valid ways to check if an estimator has been fitted using check is fitted. This option is correct. D. All of the above. A machine learning algorithm that learns from data and can make predictions or decisions based on that learning. Examples include logistic regression, decision tree classifier, random forest regressor, etc. A method in scikit-learn estimators that trains the model on a dataset. It takes the features X and target variable Y as input and adjusts the model's internal parameters to learn the relationship between them. For example, model, fit X train, Y-train trains a model using the training data X-train and Y-train, a method used to make predictions on new, unseen data using the trained model. It takes the features of the new data as input and generates predictions based on the learned model. Parameters. For instance, predictions model, PredictXTest uses a trained model to predict the target variable for the new data XTest, a function in sklearn, utils, validation used to verify whether a model has been fitted. It checks for the presence of specific attributes like intercept that are set during the fitting process. It raises an error if these attributes are not found, indicating that the model has not been trained. Example: sklearn, utils, validation, check is fitted model. Internal properties of an estimator that are typically set during the fitting process. Training in used for predictions. Core represents the coefficients of the linear model like in logistic regression, while intercept is the constant term in the model. These attributes are essential for making predictions and indicate whether the model has been trained. Error prevention ensure a model has been fitted before making predictions to avoid unexpected errors. Imagine you have a model that makes predictions on customer churn. Using check is fitted before calling model. Predict ensures that the model has been trained on historical data and will not throw an error during prediction. Model integrity verify that the model has been trained correctly and its internal state is ready for use. For example, in a credit risk assessment model, check is fitted can help you confirm that the model has been trained on a representative dataset and its parameters are appropriate for accurate predictions. Workflow control check the status of a model in a pipeline, ensuring tasks are performed in the right order. In a machine learning pipeline where data is pre-processed, features are engineered, and models are trained, check is fitted can be used to verify that a model has been trained before proceeding to the next step, like prediction or evaluation. What is the primary purpose of the check memory function in scikit-learn's utils validation module? To ensure data types are consistent throughout a machine learning pipeline. To verify if sufficient memory is available before a computationally intensive operation. To prevent memory leaks by identifying and releasing unused memory. To cache computationally expensive operations for faster execution. To ensure data types are consistent throughout a machine learning pipeline. False. The check memory function is not directly involved in data type validation. Data type checks are handled by other functions within scikit-learn's utils validation module, such as checkarray or checkxe. To verify if sufficient memory is available before a computationally intensive operation. False. While check memory is related to memory management, its primary goal is not to check memory availability. It's more focused on caching results to improve performance. To prevent memory leaks by identifying and releasing unused memory. False. The check memory function doesn't actively deal with memory leaks. It primarily acts as a cache, storing results to optimize computations. To cache computationally expensive operations for faster execution. True. This is the correct answer. The check memory function effectively caches the outputs of time-consuming operations like model fitting or feature transformations. This prevents redundant computation and accelerates subsequent requests for the same operations. D. The primary purpose of the check memory function is to improve the efficiency of model training in evaluation by caching computationally expensive operations. It stores the outputs of these operations in memory, avoiding redundant computation and accelerating subsequent requests for the same operations. 1. Model training. When training a complex model with a large dataset, model fitting can be computationally intensive. Check memory can cache the results of the fitting process, allowing for faster retraining or evaluation with different hyperparameters. Imagine training a deep neural network on a large image dataset. The model fitting process can take hours. Using check memory, we can cache the fitted model weights. If we later need to retrain the model with slightly different hyperparameters, we can load the cached weights and continue training from that point, saving significant time. 2. Feature engineering. When applying computationally expensive feature transformations, e.g., PCA or feature scaling, check memory can cache the transformed data, avoiding repeated transformation and speeding up subsequent model training or prediction. Suppose we have a dataset with many features, and we want to apply principal component analysis (PCA) to reduce dimensionality. PCA is computationally expensive. Using check memory, we can cache the PCA transformed data. If we then train a model on this transformed data, we can load the cached results instead of performing PCA again, speeding up the training process. 3. Cross-validation. In cross-validation, models are trained and evaluated multiple times on different subsets of the data. Check memory can cache the results of model training and evaluation on each fold, significantly reducing the overall cross-validation time. Consider a 5-fold cross-validation process where we train and evaluate a model on each fold. Check memory can cache the trained models and their evaluation scores on each fold. In the subsequent folds, we can load these cached results instead of retraining models from scratch, significantly speeding up the cross-validation process. 4. Hyperparameter tuning. When searching for optimal hyperparameters, models are trained and evaluated with various parameter combinations. Check memory can cache the results of each parameter combination, accelerating the hyperparameter tuning process. Let's say we want to find the best learning rate for a machine learning model. We might train and evaluate the model with different learning rates. Using check memory, we can cache the results of training with each learning rate. When we later want to try a new learning rate, we can check the cache and potentially load the cached results, avoiding the need to retrain the model from scratch for that particular learning rate. 1. Memoization. A technique used to speed up program execution by storing the results of expensive function calls and returning the cached results when the same input is encountered again. In a recursive Fibonacci sequence function, memoization can store the results of previously calculated Fibonacci numbers. When the function is called again with the same input, it can directly return the cached result instead of recalculating it. 2. Caching. A general concept of storing frequently accessed data in a temporary location like memory or disk to reduce retrieval time for subsequent requests. Web browsers use caching to store frequently accessed web pages and assets like images locally. When you revisit the same web page, your browser can load the cached version from your local storage instead of re-downloading it from the server, speeding up page loading. 3. Computational complexity, a measure of the time and space resources required to execute a given algorithm or computation. The complexity of an algorithm can be expressed using big O notation. For example, an algorithm with on complexity indicates that the time required to execute the algorithm grows linearly with the input size n. From sklearn, utils, validation import check memory. Memory check memory cache dummy cache. Define a computationally expensive function. Def expensive operation data. Perform computationally intensive tasks. Return result. Call the function with caching. Result memory, cache expensive operation data. This code snippet demonstrates how to use check memory in Python. It defines a function named expensive operation, which performs computationally intensive tasks. The memory object is created using check memory to manage the cache. The cache method of memory is used to decorate the expensive operation function, enabling caching. When the function is called with data, the cached result is retrieved if available, otherwise the function is executed, and its result is stored in the cache for future use. LT font style font size 16 px GT question LT font GT LT BR GT LT font style font size 14 px GT. Which of the following functions is the most appropriate to efficiently determine if the relationships in are symmetric? LT font GT. The question asks you to identify the most suitable function from the given options to efficiently check if the relationships represented by the NumPy array are symmetric. LT font style font size 14 px GTA. NP, all closer, arranged by TLT font GT. LT font style font size 14 px GT1. NP, all closer, arranged by T. This function checks for element-wise near equality. It's useful for comparing arrays with floating point values, where small differences due to rounding errors might be expected. LT font GT. This option utilizes NP, all close, which compares arrays for near equality, accounting for potential small differences due to floating point arithmetic. This makes it suitable for checking symmetry where slight variations in values due to rounding might occur. True. LT font style font size 14 px GTB. NP, array equaler, arranged by TLT font GT. LT font style font size 14 px GT2. NP, array equaler, arranged by T. This function checks for strict equality. It returns true if the arrays have the same shape and elements, and false otherwise. For integer arrays, where small differences are unlikely, this is a good option. LT font GT. This option uses NP, array equal, which enforces strict equality, checking for identical shapes and elements. This is suitable for situations where exact matches are required, particularly for integer arrays where rounding errors are less likely. True. LT font style font size 14 px GTC. sklearn, utils, validation, check symmetric RRLT font GT. LT font style font size 14 px GT3. sklearn, utils, validation, check symmetric. This function specifically designed for checking symmetry in matrices. It returns true if the matrix is symmetric are arranged by T and raises an error if it's not. It also handles non-square matrices appropriately. LT Font GT. This option leverages the sklearn, utils, validation, check symmetric function which is specifically designed to verify the symmetry of matrices. It directly compares the original matrix with its transpose, returning true if they are identical and raising an error if not. This function is ideal for scenarios where you want a dedicated tool for symmetry checks and potentially handling non-square matrices. True. LT font style font size 14px GTD. All of the above. LT font GT. LT font style font size 16px answered font GT LTBR GT LT font style font size 14px GTD. All of the above. LT font GT. The correct answer is option D. All of the above. Each of the provided options offers a valid method to check for symmetry in a NumPy array. The choice depends on the specific requirements of your task and the nature of the data in the array. True. LT font style font size 14px GT NumPy arrays LT font GT. NumPy arrays are the fundamental building blocks for numerical computation in Python. They provide efficient storage and manipulation of multidimensional data, crucial for tasks like checking array properties. LT font style font size 14px GT array transposed font GT. Array transpose is a matrix operation that swaps rows and columns. It is essential for verifying symmetry because a symmetric matrix remains the same after transposition. LT font style font size 14px GT element-wise comparison LT font GT. Element-wise comparison involves comparing corresponding elements of two arrays. This is a core concept in checking for symmetry, where you need to ensure every element in the original array is equal to its counterpart in the transposed array. LT font style font size 14px GT matrix symmetric font GT. Matrix symmetry refers to the property where a matrix is equal to its transpose. This concept directly relates to the quiz question, as you are seeking to determine if the relationships represented in the array exhibit this property. LT font style font size 14px GT sklearn, utils, validation LT font GT. The sklearn, utils, validation module in scikit-learn provides various utility functions for data validation and pre-processing. The check symmetric function is a valuable tool within this module for ensuring the symmetry of matrices. LT font style font size 14px GT check symmetric function LT font GT. The check symmetric function from sklearn, utils, validation specifically designed to check if a matrix is symmetric. It is a convenient tool for data validation and can handle potential exceptions like non-square matrices. LT font style font size 16px GT USE cancelled font GT LTBR GT LT font style font size 14px Imagine you are building a recommendation system for a social network. Your array R stores the number of times users have interacted with each other. If user A has interacted with user B X times, you'd expect user B to have interacted with user A X times as well. Using check symmetric ensures that your interaction data is consistent and reflects genuine user relationships. LT font GT. In a social network recommendation system, A NumPy array could store user interaction data. The value at row I and column j would represent the number of interactions between users I and j. The symmetry check is crucial here to ensure that if user A has interacted with user B x times, then user B should also have interacted with user A x times. Using check symmetric validates the data consistency and reflects genuine user relationships. Let's say we have a NumPy array R representing interactions between 4 users. R0, 2, 1, 0, 2, 0, 0, 3, 1, 0, 0, 1, 0, 3, 1, 0. This array shows that user 1 has interacted with user 2 twice, R1, 2. User 3 once, R2, 1. And so on. Applying check symmetric or any of the other methods would verify that this array is symmetric. Ensuring consistent interaction data. Which statement accurately describes the behavior of sklearn, utils, validation, columnar 1D function? Ensures a given input is a 1D array, regardless of its initial shape. Converts a 2D array to a 1D array, preserving the order of elements. Handles both 1D and 2D arrays, returning a 1D array if the input is 2D. Throws an error if the input is not a 1D array. False. This statement is partially correct. But it's not the whole story. The columnar 1D function does convert 2D arrays to 1D. But it doesn't force a 1D shape on any input. If you pass a 1D array, it remains unchanged. False. This statement is partially correct. But it's not the whole story. It accurately describes what happens to 2D arrays. But the function also handles 1D arrays without modifying them. True. This is the correct answer. The function handles both 1D and 2D arrays. And in the case of a 2D array, it returns a 1D array by flattening the input while preserving the order of elements. False. This statement is incorrect. The columnar 1D function is designed to handle both 1D and 2D inputs. It doesn't throw an error for 2D arrays. C. Handles both 1D and 2D arrays, returning a 1D array if the input is 2D. A single-dimensional array containing a linear sequence of elements. Imagine storing the daily temperature readings for a week. This data could be represented as a 1D array where each element represents the temperature for a specific day. A two-dimensional array, representing data in rows and columns, like a table. Consider a sales report for different product categories. A 2D array can be used to store this data, with each row representing a product category and each column representing a different sales metric. E.g., sales volume, revenue. Transforming raw data into a format suitable for machine learning algorithms. Before feeding data to a machine learning model, it's often necessary to perform tasks like scaling numerical features, e.g., converting values to a specific range or converting categorical features into numerical representations. This data preprocessing step ensures that the data is suitable for the algorithm and avoids potential issues. Mathematical models used for learning patterns from data. Consider a spam detection system. An algorithm like a naive Bayes classifier can be trained on a data set of emails labeled as spam or not spam. This algorithm learns patterns and probabilities from the data and can then predict whether a new email is spam or not. Predicting continuous target values based on input features, requiring a 1D array of target values. Suppose you want to predict house prices based on factors like square footage, number of bedrooms, and location. You could use a linear regression model, where the target variable is the house price, a continuous value, and the input features are the other factors. The columnar 1D function would ensure the target variable is in a 1D array format for the regression model, classifying data into categories, typically expecting a 1D array of labels. Imagine a system that categorizes customer reviews as positive or negative. A logistic regression model could be trained on a dataset of reviews labeled as positive or negative. The columnar 1D function would ensure the labels positive or negative are in a 1D array format, which is a typical requirement for logistic regression models. Finding optimal boundaries to separate data points, working efficiently with 1D arrays. Consider an image classification task where you want to differentiate between images of cats and dogs. An SVM model could be used to find a boundary that separates the cat images from the dog images in a multi-dimensional feature space. The columnar 1D function could be helpful in ensuring that the features extracted from the images are in a 1D array format, which is suitable for most SVM implementations. Consider a custom estimator class in scikit-learn that involves a parameter named threshold that is used during model fitting. Which of the following methods can you utilize to determine if this threshold parameter is indeed used for fitting the model? A. sklearn, utils, validation, hasFit parameter estimator, parameter name threshold. B. sklearn, utils, validation, check hasFitted estimator. C. estimator, get params deep true. D. estimator, fitx, y. sklearn, utils, validation, hasFit parameter estimator, parameter name threshold. True. This function specifically checks if a provided parameter is used during the fit method of an estimator. It examines the signature of the fit method to determine if the specified parameter is present. In this case, by calling hasFit parameter estimator, parameter name threshold, we can accurately verify whether threshold is utilized in the model's fitting process. Custom estimators. hasFit parameter function, fit method, sklearn, utils, validation, check hasFitted estimator. False. This function checks whether an estimator has been fitted trained on data but doesn't specifically examine which parameters were used during fitting. It's primarily for ensuring a model has been trained before using methods like predict or transform. Check hasFitted function. Estimator, get params deep true. False. This method returns a dictionary of all parameters and their values that can be set for an estimator. It shows the available parameters but doesn't indicate whether they are used during the fitting process. Custom estimators. Get params method. Estimator, fitx, y. False. This is the method for training the model. It doesn't directly tell you whether a specific parameter is used during fitting. You would need to inspect the model's code or use other functions to determine parameter usage. A. sklearn, utils, validation, hasFit parameter estimator, parameter name threshold. Creating your own machine learning models in scikit-learn by defining classes that inherit from sklearn, base, Base estimator or sklearn, base, regressor mixin for regression. Python. From sklearn, base import base estimator. Regressor mixin. From sklearn, utils, validation import hasFit parameter. Class my custom regressor base estimator. Regressor mixin. Def in itself. Threshold 0.5. Self. Threshold. Def fit self. X. Y. Your custom fitting logic here. Using self. Threshold. Return self. Def predict self. X. Your custom prediction logic here. Return predictions. Example usage. Model my custom regressor threshold 0.7. Print fit parameter model. Parameter name threshold output true. This function is part of sklearn, utils, validation module and helps determine if a specific parameter is used by an estimator's fit method. Python. From sklearn, utils, validation import hasFit parameter. Your custom estimator class defined above. Model my custom regressor threshold 0.7. Print fit parameter model. Parameter name threshold output true. Used to ensure that an estimator has been trained on data before attempting to use. Methods like predict or transform. Python. From sklearn, utils, validation import check is fitted. Your custom estimator class defined above. Model my custom regressor threshold 0.7. Checkers fitted model raises an exception if model is not fitted. Returns a dictionary of all parameters and their values that can be set for an estimator. Python. Your custom estimator class defined above. Model my custom regressor threshold 0.7. Print model, get params deep true output threshold 0.7. The core method for training a machine learning model in scikit-learn. It takes input data x and target values y to learn the model's parameters. Python. Your custom estimator class defined above. Model my custom regressor threshold 0.7. Model, fit x train. Y-train trains the model using training data. Use cases of hasFit parameter function in scikit-learn. Ensuring a parameter is truly used for model fitting, especially when creating custom estimators. Debugging custom estimators to understand parameter flow and ensure proper functionality. Ensuring code consistency and preventing errors when using custom estimators. Which of the following is not a method estimator in scikit-learn? A. Pipeline. B. Grid search CV. C. Random forest classifier. D. Stacking classifier. A sequence of estimators, each transforming the data before passing it to the next. False. Pipeline a sequence of estimators, each transforming the data before passing it to the next. Finds the optimal hyperparameters for an estimator by trying out different combinations. False. Grid search CV finds the optimal hyperparameters for an estimator by trying out different combinations. An ensemble method that constructs multiple decision trees and combines their predictions. True. Random forest classifier an ensemble method that constructs multiple decision trees and combines their predictions. Combines multiple classifiers base estimators to make a final prediction. False. Stacking classifier combines multiple classifiers base estimators to make a final prediction. C. Random forest classifier. Method estimators in scikit-learn are algorithms that build upon other estimators like classifiers, regressors, etc. To create more complex models, they often combine, control, or optimize the behavior of underlying estimators. Meta-estimators in scikit-learn are algorithms that build upon other estimators like classifiers, regressors, etc. To create more complex models, they often combine, control, or optimize the behavior of underlying estimators. These are the basic building blocks of machine learning models. They are responsible for learning patterns from data and making predictions. Classifiers, e.g., logistic regression, decision tree classifier. Regressors, e.g., linear regression, SVR. Clustering, e.g., k-means, DBSCAN. Dimensionality reduction, e.g., PCA, ELDA. Classifiers, e.g., logistic regression, decision tree classifier. Regressors, e.g., linear regression, SVR. Clustering, e.g., k-means, DBSCAN. Dimensionality reduction, e.g., PCA, ELDA. Parameters that control the learning process of an estimator. Parameters that control the learning process of an estimator. Tuned during model selection, preprocessing data, feature engineering, and model training in one sequence. Preprocessing data, feature engineering, and model training in one sequence. Finding optimal hyperparameters for models like support vector machines (SVM) or neural networks. Finding optimal hyperparameters for models like support vector machines (SVM) or neural networks. Combining different classifiers, e.g., logistic regression, naive Bayes to improve predictive accuracy. Combining different classifiers, e.g., logistic regression, naive Bayes to improve predictive accuracy. Solving classification problems like image recognition or spam detection. Solving classification problems like image recognition or spam detection. What does the available IF decorator in sklearn, utils, meta-estimators do? A. Makes a method only available if a certain attribute is present in the estimator. B. Checks if a specific function is available in the environment. C. Validates input data before a method is called. D. All of the above. True. This is a core functionality of available IF. You can specify an Husserl argument to check if a particular attribute exists within the estimator. If it doesn't, the method will be unavailable. A. Makes a method only available if a certain attribute is present in the estimator. True. The available IF decorator can use the func argument to check if a specific function is accessible. In the current environment, this allows you to conditionally use methods that depend on external functions. B. Checks if a specific function is available in the environment. True. You can utilize the check argument to provide a function that performs input data validation. This allows you to enforce specific data requirements before a method is executed. C. Validates input data before a method is called. True. All the mentioned capabilities A, B, and C are provided by the available IF decorator. It is a versatile tool for controlling method availability and validating inputs. D. All of the above. D. All of the above. Decorators. A decorator is a function that takes another function as input and returns a modified version of that function. It provides a way to enhance or alter the behavior of a function without directly changing its code. Implementing logging, caching, or performance profiling for a function. Meta-estimators. Meta-estimators in scikit-learn are classes that can create and manage other estimators. They offer a higher level of abstraction, allowing you to compose complex machine learning pipelines by combining different estimators. Creating a pipeline that includes feature selection, model training, and hyperparameter tuning. sklearn, utils, meta-estimators. This module provides utility functions and decorators for building meta-estimators in scikit-learn. It offers tools like available if delegate has method, and safesetiter, which enhance the development of custom meta-estimators. Creating a custom meta-estimator that dynamically adapts its behavior based on the features or capabilities of its underlying estimators. Let's say we have a dataset with two features x1, x2 and a target variable y. We want to use a linear regression model to predict y based on x1 and x2. However, before training the model, we want to check if the dataset has a minimum number of samples. If it doesn't, we want to raise an error. We can use the available if decorator with a custom validation function to achieve this. You have an imbalanced dataset where class 0 has 90 of the data and class 1 has 10. Which of the following statements is true about the class weight parameter in scikit-learn? It automatically balances the dataset by oversampling minority class data. It automatically balances the dataset by undersampling majority class data. It assigns weights to each class based on their relative frequency, penalizing the model for misclassifying minority class samples. All of the above. Incorrect. The class weight parameter doesn't directly perform oversampling. Oversampling is a separate technique for handling imbalanced datasets. Oversampling, creating copies of minority class samples to balance the dataset. Incorrect. The class weight parameter doesn't directly perform undersampling. Undersampling is a separate technique for handling imbalanced datasets. Undersampling, removing samples from the majority class to balance the dataset. Correct. The class weight parameter in scikit-learn assigns weights to each class based on their relative frequency, penalizing the model for misclassifying minority class samples. This helps in improving the model's performance on the minority class. Class weights. Weights assigned to each class during model training to adjust for class imbalances. Incorrect. Only option C is correct. Class weights. Weights assigned to each class during model training to adjust for class imbalances. It assigns weights to each class based on their relative frequency, penalizing the model for misclassifying minority class samples. Imbalanced dataset. A dataset where the number of samples in one or more classes significantly outnumbers the others. Oversampling. Creating copies of minority class samples to balance the dataset. Undersampling. Removing samples from the majority class to balance the dataset. Class weights. Weights assigned to each class during model training to adjust for class imbalances. sklearn, utils, class weight. A function in scikit-learn that calculates class weights based on different strategies. Fraud detection, identifying fraudulent transactions in a dataset where the majority are legitimate. Medical diagnosis, recognizing rare diseases in a population where most cases are common. Spam detection, identifying spam emails in a dataset where most are legitimate. 90-10. Class weights are calculated based on the inverse of the class frequency. In this case, the weight for class 0 would be 10.91.11 and for class 1 would be 10.110. This means that the model is penalized 10 times more for misclassifying a sample from class 1 compared to misclassifying a sample from class 0. Consider a dataset with two classes, class A with 1000 instances and class B with 100 instances. What would be the class weights for these classes using sklearn, utils, class weight, compute class weight with class weight balanced? A. Class A 1.0, class B 10.0. B. Class A 0.1, class B 1.0. C. Class A 1.0, class B 1.0. D. All of the above. A. Class A 1.0, class B 10.0. True. sklearn, utils, class weight, compute class weight with class weight balanced calculates class weights inversely proportional to the class frequencies. In our example, class A has 10 times more instances than class B. Therefore, class B receives a weight 10 times higher than class A to balance the class distribution. The formula for calculating class weight using compute class weight with class weight balanced is weight n samples n classes np, bin county. Therefore, the class weights are calculated as follows: class A weight 1000, 100, 2, 1000, 1.0, class B weight 1000, 100, 2, 100, 1, 0.0. The correct answer is A. Class A 1.0, class B 10.0. B. Class A 0.1, class B 1.0. False. This choice is incorrect because it assigns a weight of 1.0 to class B, which is the minority class. However, the minority class should receive a higher weight to balance the class distribution, as explained in the solution. The correct answer is A. Class A 1.0, class B 10.0. C. Class A 1.0, class B 1.0. False. This choice is incorrect because it assigns equal weights to both classes, which does not address the class imbalance. The minority class needs a higher weight to compensate for its smaller size. The correct answer is A. Class A 1.0, class B 10.0. D. All of the above. False. This choice is incorrect because only option A is correct. The other options do not accurately represent the class weights calculated using sklearn, utils, class weight, compute class weight with class weight balanced. The correct answer is A. Class A 1.0, class B 10.0. A. Class A 1.0, class B 10.0. Class imbalance. A situation where one class has significantly more instances than others in a dataset. In fraud detection, the number of fraudulent transactions is typically much smaller than the number of legitimate transactions. This imbalance can lead to models that are good at detecting legitimate transactions but poor at detecting fraudulent ones. Let's say we have a dataset with 1000 instances, where 900 belong to class A and 100 belong to class B. This would be an example of class imbalance, as class A has 9 times more instances than class B. Class weights. Weights assigned to each class to address class imbalance, typically inversely proportional to class frequency. In a medical diagnosis task where the goal is to predict whether a patient has a rare disease, The model needs to be more sensitive to the minority class patients with the disease. Using class weights would assign a higher weight to the minority class, making the model more likely to correctly classify patients with the rare disease. In the previous example, we could assign a weight of 1.0 to class A and 9.0 to class B. This would effectively give the model a stronger signal to focus on correctly classifying instances belonging to class B. sklearn, utils, class weight, compute class weight. A function in scikit-learn that calculates class weights based on different strategies balanced subsample, etc. In a spam filtering scenario, we can use compute class weight to assign higher weights to spam emails, making the model more adept at identifying them. We can use different strategies like balanced or balanced subsample depending on the nature of the imbalance and the desired outcome. Suppose we have a dataset with 1000 emails, where 950 are legitimate and 50 are spam. Using compute class weight with class weight balanced would give spam emails a higher weight to help the model better distinguish them from legitimate emails. Class weight balanced specifies that weights should be inversely proportional to class frequencies. In image classification, if we have a dataset with many images of common objects e.g. cars, dogs and few images of rare objects e.g. airplanes, cats, we can use class weight balanced to ensure that the model learns to classify both common and rare objects accurately. Let's say we have 1000 images, where 800 are cars and 200 are airplanes. Using class weight balanced, the model would assign a weight of 1.0 to cars and 4.0 to airplanes, making it more attentive to airplanes and reducing the chances of misclassification. How do you compute sample weights using the sklearn, utils, class weight, compute sample weight function? Using the class weight parameter directly within the classifier. B. Passing the class weight parameter to the compute sample weight function. C. Using the sample weight parameter in the classifier, with weights computed beforehand. D. All of the above. This is correct. The class weight parameter is available in many classifiers in scikit-learn, like logistic regression, random forest classifier, etc. It directly takes a dictionary or a string balanced to automatically compute class weights. True. A LT font color को 0000FF quotient class weight LT font TGT is a parameter available in many classifiers in scikit-learn like LT font color को 0000FF quotient logistic regression, random forest classifier LT font TGT etc. That directly takes a dictionary or a string balanced to automatically compute class weights. This is also correct. The compute sample weight function can be used to calculate sample weights based on predefined class weights. It takes the class weights and the target labels as input, and computes the sample weights accordingly. True. B. The LT font color को 0000FF quotient computes sample weight LT font TGT function can be used to calculate sample weights based on predefined class weights. This function takes the class weights and the target labels as input, and computes the sample weights accordingly. This is correct as well. You can compute class weights beforehand using class weight, compute class weight and then pass those weights to the sample weight parameter in the classifier. True. See, you can compute class weights beforehand using LT font. Calico 0000FF quotient class weight. Compute class weight LT font TGT and then pass those weights to the LT font Calico 0000FF quote GTS ample weight LT font TGT parameter in the classifier. Since all of the above methods are valid ways to compute sample weights using a computes ample weight function, this is the correct answer. True. D. All of the above. D. All of the above. A situation where the target classes in a dataset have significantly different frequencies. Fraud detection dataset where most transactions are non-fraudulent, while only a small percentage are fraudulent. A situation where the target classes in a dataset have significantly different frequencies. Numerical values assigned to different classes to account for class imbalance. Giving higher weights to the minority class fraudulent transactions to make the algorithm focus on identifying them. Numerical values assigned to different classes to account for class imbalance. Individual weights assigned to each data sample during training. These weights influence the learning process, giving more importance to samples with higher weights. Individual weights assigned to each data sample during training. A module in scikit-learn providing functions to compute class weights and sample weights. It helps in addressing class imbalance and improving model performance on imbalanced datasets. A module in scikit-learn providing functions to compute class weights and sample weights. Fraud detection. Medical diagnosis. Image classification with rare objects. Text classification with imbalanced categories. Use cases. Let's say you have a dataset with 1000 samples, where 900 belong to class A and 100 belong to class B. You want to give more weight to class B to ensure the model learns better from its examples. You could use class weight, compute class weight with balanced to compute class weights. This would result in higher weights for class B, making the model focus more on correctly classifying class B samples during training. 900. 100. From sklearn, utils, class weight import compute class weight. Class weights compute class weight balanced. Classes 0, 1, yo 900, 100. Print class weights. Which of the following techniques is commonly used in scikit-learn sklearn for multi-class classification problems? A. 1 vs rest. B. 1 vs 1. C. Both A and B. D. None of the above. Correct. 1 vs rest OVR is a strategy used in sklearn for multi-class classification. It works by training the separate binary classifier for each class, with all other classes grouped as a single negative class. 1 vs rest OVR. Correct. 1 vs 1 OVO is another strategy used in sklearn for multi-class classification. It involves training the separate binary classifier for each pair of classes. 1 vs 1 OVO. Correct. Both 1 vs rest and 1 vs 1 are commonly used strategies in sklearn for multi-class classification. They are implemented using the 1 vs rest classifier and 1 vs 1 classifier classes, respectively. Solution. Incorrect. As mentioned earlier, both 1 vs rest and 1 vs 1 are commonly used in sklearn for multi-class classification. Solution. C. Both A and B. A type of classification problem where the target variable has more than two classes. Image classification, e.g., recognizing different types of animals, objects. Sentiment analysis, classifying text as positive, negative, or neutral. Customer churn prediction, identifying customers likely to leave a service. Medical diagnosis, classifying diseases based on symptoms. Multi-class classification. Train one binary classifier for each class, with all other classes grouped as a single negative class. Image classification, where you want to distinguish between different types of animals, like cats, dogs, and birds. Sentiment analysis, where you need to classify text as positive, negative, or neutral. 1 vs REST OVR. Train a separate binary classifier for each pair of classes. Customer churn prediction, where you want to identify customers likely to leave for different reasons, like price, service, or competition. Medical diagnosis, where you need to distinguish between different types of diseases based on a set of symptoms. 1 vs 1 OVO. A type of classification problem where the target variable has only two classes. Spam detection, classifying emails as spam or not spam. Fraud detection, classifying transactions as fraudulent or legitimate. Binary classification. A machine learning model that learns to predict the class of a given input data. Logistic regression. Support vector machines, SVM. Classifier. Suppose you have a dataset of fruits with three classes: apples, oranges, and bananas. You want to build a multi-class classifier to predict the type of fruit based on its features, e.g., color, size, shape. You would train three binary classifiers: one for apples, apples vs not apples; one for oranges, oranges vs not oranges; and one for bananas, bananas vs not bananas. Each classifier would treat all other classes as the negative class. You would train three binary classifiers: one for apples vs oranges, one for apples vs bananas, and one for oranges vs bananas. Each classifier focuses on discriminating between two specific classes. You are working on a machine learning project to classify different types of fruits: apple, banana, orange, grape based on their features. You are using scikit-learn's type of target utility. What type of target variable does this data represent? Binary, multi-class, multi-label. All of the above. Incorrect. Binary classification involves only two categories, whereas our fruit classification has four distinct categories. Correct, as we have more than two classes: apple, banana, orange, grape to classify. This aligns perfectly with multi-class classification. Incorrect. Multi-label classification allows assigning multiple labels to a single data point, which is not applicable in our scenario where each fruit belongs to only one class. Incorrect. While the data fits the multi-class definition, it doesn't align with binary or multi-label classification. Therefore, all of the above is incorrect. Multi-class. Classifying data into more than two categories. Image recognition, identifying different types of animals. A function within scikit-learn that helps determine the type of target variable in a dataset. Analyzing and understanding data before applying appropriate machine learning models. The specific function call to use within scikit-learn to determine the type of target variable. Analyzing and understanding data before applying appropriate machine learning models. Apple, banana, orange, grape. 10, 5, 8, 7, 6, 9, 4, 11. In this example, we have 4 fruits with their corresponding features. Using type of target, scikit-learn would identify this as multi-class data since we have multiple distinct fruit classes. In scikit-learn, what does the is multi-label function from sklearn, utils, multi-class help determine? Whether a classification problem involves multiple labels or not. The number of classes in a classification problem. Whether a dataset is balanced or not. The average accuracy of a multi-class classification model. Whether a classification problem involves multiple labels or not. The is multi-label function is designed to determine whether a classification problem deals with multiple labels per data point. LTBRGT. Let's visualize how this works with a simple example of a dataset containing information about movies. Imagine our dataset has information about movies, their genres, and whether they are rated as family friendly. We'll use the genres column to explore this concept. Correct. The is multi-label function in scikit-learn is specifically designed to identify multi-label classification problems, where each data point can be assigned multiple labels simultaneously. In our movie example, if a movie can belong to multiple genres e.g. action and comedy, it is a multi-label classification scenario. The number of classes in a classification problem. The is multi-label function is designed to determine whether a classification problem deals with multiple labels per data point. LTBRGT. Let's visualize how this works with a simple example of a dataset containing information about movies. Imagine our dataset has information about movies, their genres, and whether they are rated as family friendly. We'll use the genres column to explore this concept. Incorrect. The is multi-label function doesn't determine the total number of classes. While the concept of multiple labels is related to the number of classes, is multi-label focuses specifically on whether each data point can have more than one label. Whether a dataset is balanced or not. The is multi-label function is designed to determine whether a classification problem deals with multiple labels per data point. LTBRGT. Let's visualize how this works with a simple example of a dataset containing information about movies. Imagine our dataset has information about movies, their genres, and whether they are rated as family friendly. We'll use the genres column to explore this concept. Incorrect. The is multi-label function doesn't assess the balance of a dataset. Dataset balance refers to the distribution of labels, where an imbalanced dataset has significantly more instances of one class than others. This is separate from the concept of multiple labels per data point. The average accuracy of a multi-class classification model. The is multi-label function is designed to determine whether a classification problem deals with multiple labels per data point. LTBRGT. Let's visualize how this works with a simple example of a dataset containing information about movies. Imagine our dataset has information about movies, their genres, and whether they are rated as family friendly. We'll use the genres column to explore this concept. Incorrect. The is multi-label function doesn't calculate or provide the average accuracy of a model. Model performance metrics like accuracy are separate from the function's purpose of identifying Multilabel classification problems. Whether a classification problem involves multiple labels or not. A type of classification where each data point can have one or more labels. Image tagging multiple objects in a single image. Text categorization multiple topics within a document. Movie A, Movie B, Movie C, Movie D. Action, comedy, romance, drama, thriller, horror, comedy, sci-fi. Yes, no, no, yes. In this example, the genres column represents a multilabel classification scenario because each movie can have multiple genres assigned to it. For instance, movie A is classified as both action and comedy. A function that helps to determine whether a classification problem is multilabel. I is multilabelly where y is the target variable. True if the classification problem is multilabel and false otherwise. From sklearn, utils, multiclass import is multilabel. Y action, comedy, romance, drama, thriller, horror, comedy, sci-fi. Print is multilabelly. True. The function returns true because the target variable y contains data points with multiple labels, separated by commas, indicating a multilabel classification problem. You are building a multi-class classification model to predict the type of flower Iris setosa. Iris versicolor. Iris virginica based on sepal and petal measurements. You have trained your model and obtained predictions for a new dataset. How do you efficiently extract the unique flower types present in your predictions? Use NP, unique predictions. Apply set predictions. Utilize sklearn, utils, multi-class, unique labels predictions. All of the above. All of the above. Use NP. Unique predictions. NP, unique predictions will return the unique elements from the predictions array. Sorted in ascending order. For instance, if the predictions array is 0, 2, 1, 2, 0, 1, NP, unique predictions would output 0, 1, 2. This is correct because it effectively extracts the unique flower types from your predictions. True. Apply set predictions. Set predictions creates a set from the predictions array. A set is an unordered collection of unique elements. If the predictions array is 0, 2, 1, 2, 0, 1, set predictions would output 0, 1, 2. The order might not be the same. This is correct because sets are designed to hold only unique elements. True. Utilize sklearn, utils, multi-class, unique labels predictions. sklearn, utils, multi-class, unique labels predictions is designed for multi-class classification problems. It handles the specific nature of labels in such problems and ensures the output is compatible with other sklearn functions. If the predictions array is 0, 2, 1, 2, 0, 1, sklearn, utils, multi-class, unique labels predictions would output 0, 1, 2. This is correct because it is specifically built for multi-class scenarios and ensures compatibility. True. All of the above. All the provided options can be used to extract unique labels from predictions in a multi-class classification problem. The specific choice depends on your preference and the context. True. Multi-class classification. A classification problem where the target variable has more than two categories. Example: classifying flower species Iris setosa. Iris versicolor, Iris virginica. In the iris dataset, you are trying to classify flowers into three distinct species: Iris setosa, Iris versicolor, and Iris virginica. NumPy NP, unique, returns the unique elements of an array in sorted order. If you have an array data 1, 2, 2, 3, 4, 4, 5, NP, unique data will give you 1, 2, 3, 4, 5. Python set, an unordered collection of unique elements. You can create a set using mySet1, 2, 3, 3, 4, and it will automatically remove duplicates resulting in 1, 2, 3, 4. sklearn, utils, multi-class, unique labels. Specifically designed for multi-class classification problems, it extracts unique labels from input data, often predictions or target variables. In the iris dataset, after training your model, you can use sklearn, utils, multi-class, unique labels predictions to discover the unique flower types. Your model predicts. Use cases. 1. LTBGT understanding model performance. LTBGT after training a multi-class model. Identify which labels the model predicts. You've trained a model to predict the type of car sedan, SUV, truck based on features like price, fuel efficiency, and size. Using sklearn, utils, multi-class, unique labels predictions after testing on a new dataset helps you understand which car types your model accurately predicts. 2. LTBGT data analysis. LTBGT discover the unique categories present in a multi-class dataset. You are analyzing a dataset of different types of fruits: apple, banana, orange, grape. You can use NP, unique, to quickly see the distinct fruit types in the dataset. 3. LTBGT model interpretation. LTBGT determine which classes your model has learned to recognize. You trained a model to classify images of animals: cat, dog, bird. After training, you can use sklearn, utils, multi-class, unique labels predictions to see which animal classes your model has learned to recognize reliably. Which of the following functions in XMart is used for computing the row-wise or column-wise sum of a matrix or array? A. Safesparse. B. LogsUmakeup. C. Row norms. D. Sparsematrix. E. All of the above. This function handles the multiplication of two matrices or arrays, at least one of which is sparse, in a safe and efficient manner. However, it doesn't directly compute row-wise or column-wise sums. False. Calculates the log of the sum of exponentials of input elements, providing numerical stability. However, its primary purpose is not row or column summation. False. This function efficiently computes the L2 norm of each row in a matrix or array. This essentially calculates the Euclidean length of each row vector, but it doesn't directly compute the row sum. For a matrix with all elements equal to 1, the row norm is equivalent to the row sum. True. Offers optimized multiplication between a sparse matrix and a dense matrix, but it does not directly calculate row or column sums. False. The XMart module provides various functions like safesparse. LogsUmakeup, row norms, and sparsematrix. Among others, to handle operations with matrices and arrays efficiently. Row norms computes the Euclidean length of each row vector. which is effectively the row sum if you are dealing with a matrix of ones. True. All of the above. Sparse matrices. Representing matrices with many zero elements efficiently. Using formats like compressed sparse row CSR or compressed sparse column CSC. Imagine a matrix representing user item ratings in a recommender system. Most users haven't rated most items, resulting in many zeros in the matrix. Sparse matrix formats store only the non-zero values, saving memory and computation. Matrix multiplication. Multiplying two matrices, which is a fundamental operation in linear algebra. SafeSparse handles this for sparse matrices. In a machine learning model, you might multiply a matrix of features sparse with a matrix of weights to obtain predictions. SafeSparse efficiently handles this multiplication for sparse matrices. Log sum exp. A technique for numerically stable computation of the log of the sum of exponentials. Often used to avoid underflow issues in calculations. In a probabilistic model, you might need to calculate the sum of probabilities over a large set of possibilities. Log sum exp ensures that these calculations don't result in underflow errors due to extremely small probabilities. Vector norms. Quantifying the magnitude or length of vectors, with L2 norm being the Euclidean length. In image processing, you might compute the difference between two images by calculating the L2 norm of their pixel differences. This norm represents the overall difference in brightness between the images. Recommender systems. Calculating similarities between items or users based on sparse matrices. In a movie recommender system, you might have a sparse matrix representing user ratings for movies. SafeSparse could be used to calculate similarities between movies based on user ratings, which helps recommend similar movies to users. Natural language processing (NLP). Handling large text data, often represented as sparse matrices. In NLP, a document can be represented as a sparse matrix where each row represents a word and each column represents a document. Sparse matrix. Could be used for efficient operations like computing document similarities or finding relevant documents based on keywords. Computer vision. Analyzing images, which can be represented using sparse matrices. In image processing, features like edges or corners can be represented using sparse matrices. Row norms could be used to calculate the magnitude of these features, which can help in object detection or image segmentation. Consider a scenario where you need to perform a matrix multiplication between a dense matrix and a sparse matrix. Which of the following statements accurately describes the behavior of sklearn, utils, xsmart, SafeSparse. In this context? A. It performs the matrix multiplication directly, without any special handling for sparsity. B. It leverages the sparse matrix representation to efficiently compute the dot product, potentially avoiding unnecessary computations. C. It always converts the sparse matrix to a dense format before performing the dot product, regardless of the efficiency implications. This statement is incorrect. SafeSparse. Specifically handles sparse matrices efficiently. It doesn't simply perform a direct multiplication, which would be inefficient for sparse matrices. A. It performs the matrix multiplication directly, without any special handling for sparsity. This statement is correct. SafeSparse. Is designed to take advantage of sparsity. It utilizes efficient algorithms to perform dot products, skipping computations involving zero elements in the sparse matrix. B. It leverages the sparse matrix representation to efficiently compute the dot product, potentially avoiding unnecessary computations. This statement is incorrect. Converting a sparse matrix to a dense format would be computationally expensive and defeat the purpose of using sparse matrices. SafeSparse. Avoids this unnecessary conversion. C. It always converts the sparse matrix to a dense format before performing the dot product, regardless of the efficiency implications. B. It leverages the sparse matrix representation to efficiently compute the dot product, potentially avoiding unnecessary computations. Sparse matrices are matrices where most of the elements are zero. They are commonly used to represent data with a high proportion of missing or zero values. For example, in recommendation systems or natural language processing, consider a customer product matrix representing purchases. If only a few customers buy a specific product, the matrix will be sparse, with most cells containing zero values. Dense matrices are matrices where most of the elements are non-zero. They require more memory to store compared to sparse matrices. A matrix representing the pixel values of an image is typically dense, with most cells containing non-zero values. The dot product is a fundamental mathematical operation that involves multiplying corresponding elements of two vectors and summing the results. It is used in various applications, including vector projection, similarity calculations, and matrix multiplication. The dot product of two vectors 1, 2, 3 and 4, 5, 6 is 1, 4, 2, 5, 3, 6, 3, 2. Matrix multiplication is an operation that combines two matrices to produce a new matrix. It has numerous applications in various fields, including linear algebra, computer graphics, and machine learning. Matrix multiplication of two matrices A and B results in a new matrix C, where each element of C is the sum of the products of corresponding elements of the rows of A and the columns of B. Computational efficiency refers to minimizing the computational resources required to perform a task. This includes factors like time, memory, and CPU usage. Using algorithms that exploit sparsity, like SafeSparse. Significantly improves computational efficiency when dealing with large sparse datasets. Sparse matrices are typically stored using specialized representations like CSR compressed sparse row or COO coordinate list to reduce memory consumption and enhance performance. In CSR representation, only the non-zero elements, their row indices, and column indices are stored, effectively reducing memory usage compared to storing all elements in a dense format. You have a machine learning model with several hyperparameters. You want to find the optimal range for these parameters using a randomized search. Which scikit-learn function would you use for this task? A-grid search CV. A-grid search CV. True. Grid search CV is a powerful technique for hyperparameter tuning, systematically trying out all combinations within a specified grid of parameter values. It is useful when you want to explore the entire parameter space thoroughly. This approach can be computationally expensive for larger grids. B randomized search CV. B randomized search CV True. Randomized search CV is similar to grid search CV, but instead of exploring all combinations, it randomly samples from the parameter space. This makes it more efficient for larger parameter grids, especially when dealing with many hyperparameters. It allows you to find good parameter configurations without the computational burden of exhaustively exploring the entire space. See randomized rangefinder. See randomized rangefinder. True. Randomized rangefinder is a helpful utility function for finding potential ranges for hyperparameters. It comes in handy when you are unsure about the initial search space. You can use this function to get a sense of appropriate ranges for your hyperparameters, which can then be used for grid search CV or randomized search CV. D. All of the above. D. All of the above. True. All of the provided options grid search CV, randomized search CV, and randomized rangefinder are relevant for finding optimal hyperparameters in scikit-learn, each serving a distinct purpose. Grid search CV exhaustively searches through a grid of parameter combinations. Randomized search CV samples random combinations for efficiency, and randomized rangefinder helps determine potential ranges for hyperparameters. D. All of the above. D. All of the above. True. All of the provided options grid search CV, randomized search CV, and randomized rangefinder are relevant for finding optimal hyperparameters in scikit-learn, each serving a distinct purpose. Grid search CV exhaustively searches through a grid of parameter combinations. Randomized search CV samples random combinations for efficiency, and randomized rangefinder helps determine potential ranges for hyperparameters. Hyperparameter tuning, the process of finding the best values for the parameters of a machine learning model that are not learned from the data. Adjusting the learning rate in a neural network to find a balance between speed and accuracy. A higher learning rate might lead to faster convergence but could overshoot the optimal solution, while a lower learning rate might take longer but find a more precise solution. Grid search CV, a scikit-learn function that exhaustively searches through a grid of hyperparameter combinations. Tuning the parameters of a support vector machine SVM by systematically trying out different values. For the kernel, see regularization parameter and gamma kernel coefficient. Randomized search CV, a scikit-learn function that randomly samples hyperparameter combinations, finding the optimal hyperparameters for a random forest model by randomly sampling combinations of parameters like the number of trees, maximum depth, and minimum samples per leaf. Randomized rangefinder, a scikit-learn utility function that helps find potential ranges for hyperparameters. Useful for setting up a grid search CV or randomized search CV. Determining reasonable initial ranges for the regularization parameter C in a logistic regression model by using randomized rangefinder. This helps you define the search space for grid search CV or randomized search CV. Use cases. Hyperparameter tuning techniques are broadly applicable in various machine learning scenarios, including model optimization, optimizing model parameters like learning rate, regularization strength, etc., to improve performance, tuning the learning rate in a gradient boosting machine to find the best balance between model complexity and generalization ability. Feature engineering, finding optimal parameters for feature scaling, dimensionality reduction techniques. adjusting the parameters of principal component analysis (PCA) to achieve the desired level of dimensionality reduction while preserving most of the variance in the data. Algorithm selection. Comparing different machine learning algorithms and finding their best configurations. Evaluating the performance of different classification algorithms like logistic regression, random forest, and support vector machine by tuning their respective hyperparameters and comparing their performance on a validation set. What is the primary use case for the randomized range finder function in the sklearn, utils, xmath module? A. To generate random numbers within a specified range. B. To find the optimal range for hyperparameters in machine learning models. C. To perform matrix factorization with a randomized algorithm. D. All of the above. True. 1. Generate random numbers within a specified range. It provides a convenient way to create arrays of random values, crucial for various tasks like initializing weights in neural networks or simulating data. True. 2. Find optimal hyperparameter ranges. The randomized range finder helps narrow down the search space for hyperparameter optimization techniques. By randomly sampling values within specified ranges, it can identify promising areas for more focused optimization. True. 3. Perform matrix factorization with a randomized algorithm. The randomized range finder underlies techniques like randomized SVD, which efficiently approximates the singular value decomposition of large matrices. This is valuable in dimensionality reduction, recommendation systems, and other applications. True. Therefore, all the options A, B, and C accurately describe the capabilities of the randomized range finder function. D. All of the above. Finding the best settings for model parameters that are not learned from the training data itself. In a machine learning model, tuning the learning rate, the number of hidden layers in a neural network, or the regularization parameter are all examples of hyperparameter optimization. Randomly sampling hyperparameters to explore the search space efficiently, instead of exhaustively trying all combinations of hyperparameters. Randomized search randomly selects values from a specified range for each parameter. A matrix decomposition technique used for dimensionality reduction, recommendation systems, and other applications. In image compression, SVD is used to reduce the number of bits needed to represent the image, while preserving its key features. An efficient and scalable approximation of SVD using randomization techniques. For very large matrices, traditional SVD algorithms can be computationally expensive. Randomized SVD offers a faster approximation by using random projections to reduce the dimensionality of the matrix, decomposing a matrix into a product of two or more smaller matrices. Often used for recommendation systems and collaborative filtering. Netflix uses matrix factorization to predict user ratings for movies they haven't seen. By decomposing the user movie rating matrix, it can identify latent factors like genre preference that influence user ratings. What is the purpose of randomized SVD in scikit-learn? It performs a full singular value decomposition SVD on a matrix. It computes a truncated SVD, efficiently finding the top singular values and vectors. It performs a sparse SVD, optimized for matrices with many zero entries. It performs a SVD using a randomized algorithm for faster computation. Especially for large matrices, it performs a full singular value decomposition SVD on a matrix. False. Randomized SVD doesn't perform a full SVD. It uses a randomized algorithm for a more efficient computation, particularly when you need only a subset of singular values and vectors. Singular value decomposition SVD. It computes a truncated SVD, efficiently finding the top singular values and vectors. False. While randomized SVD can compute a truncated SVD, its primary purpose is not just truncation. It's about faster computation through randomization. Truncated SVD. It performs a sparse SVD, optimized for matrices with many zero entries. False. Randomized SVD is not specifically designed for sparse matrices. There are separate techniques for sparse SVDs. None. It performs a SVD using a randomized algorithm for faster computation, especially for large matrices. True. Randomized SVD is a powerful tool for efficiently calculating SVDs of large matrices. It leverages randomization to achieve faster results, making it suitable for applications where computational efficiency is crucial. Randomized algorithms. D. Singular value decomposition SVD is a fundamental matrix factorization technique in linear algebra. It decomposes a matrix into three matrices U and V. The diagonal matrix contains the singular values, which are the square roots of the eigenvalues of the matrix's covariance matrix. U and V are orthogonal matrices, representing the left and right singular vectors, respectively. Dimensionality reduction, reducing the number of features in a dataset while preserving important information, often used in machine learning. Image compression, decomposing an image into its most important components, enabling efficient storage and transmission. Recommender systems, predicting user preferences based on their past interactions with items. Truncated SVD involves computing only the top k singular values and their corresponding vectors, where k is a predetermined number. This approach is useful when you only need a subset of the singular values and vectors, providing a more efficient computation. Image compression, reducing the number of singular values used to represent an image, resulting in a smaller file size. Recommender systems, recommending items based on a subset of user preferences. Natural language processing, analyzing text data by representing words as vectors, keeping only the most relevant dimensions. Randomized algorithms are techniques that use randomness to design efficient and practical algorithms, often achieving good solutions with high probability. They are particularly valuable for problems where finding exact solutions is computationally expensive or even impossible. Finding approximate solutions to complex problems such as finding the median in a large dataset or searching for patterns in massive amounts of data. Analyzing large-scale data, providing a way to handle massive datasets efficiently. Machine learning, speeding up training processes for models like PCA and SVD. What is the primary function of the scikit-learn randomized SVD function from the utils xtmart module? A. Computes the full singular value decomposition SVD of a matrix. B. Performs a randomized SVD, which is a faster and more memory-efficient alternative to the full SVD. C. performs a low-rank approximation of a matrix using the SVD. D. All of the above. Correct randomized SVD can compute the full SVD of a matrix when you specify the number of singular values and vectors to be equal to the minimum dimension of the matrix. A. Computes the full singular value decomposition SVD of a matrix. Correct. The core functionality of randomized SVD is to perform a randomized SVD, which is faster and more efficient than the traditional SVD, especially for large matrices. B. Performs a randomized SVD, which is a faster and more memory-efficient alternative to the full SVD. Correct randomized SVD allows for low-rank approximation by specifying the number of singular values and vectors to compute. This is useful for dimensionality reduction and compression. C. Performs a low-rank approximation of a matrix using the SVD. Correct as demonstrated by the explanations for options A, B, and C. Randomized SVD encompasses all these functionalities. Therefore, all of the above is the correct answer. D. All of the above. D. Singular value decomposition SVD. SVD is a fundamental matrix factorization technique. It decomposes a matrix into three matrices: U left singular vectors, singular values, and V right singular vectors. SVD has wide applications in linear algebra, machine learning, and data analysis. 1. Singular value decomposition SVD. Matrix factorization. Matrix factorization is the process of decomposing a matrix into a product of simpler matrices. SVD is a common type of matrix factorization used in recommender systems, image processing, and dimensionality reduction. 2. Matrix factorization. Rank approximation. Rank approximation involves finding a lower rank matrix that closely approximates the original matrix. This is often done using SVD, where the singular values are truncated to obtain a lower rank approximation. 3. Rank approximation. Latent semantic analysis (LSA). LSA is a technique that uses SVD to analyze the relationships between words and documents. It reduces the dimensionality of a document term matrix by identifying latent semantic relationships between words. 4. Latent semantic analysis (LSA). Dimensionality reduction techniques. Dimensionality reduction techniques aim to reduce the number of features in a dataset while preserving as much information as possible. SVD is one of the widely used dimensionality reduction techniques. 5. Dimensionality reduction techniques. Dimensionality reduction. In dimensionality reduction, randomized SVD can be used to project high-dimensional data onto a lower-dimensional space while retaining important information. This is useful for visualization, feature extraction, and improving the performance of machine learning algorithms. 1. Dimensionality reduction. Randomized SVD can be used to reduce the dimensionality of high-dimensional data by keeping only the most significant singular values and vectors, effectively compressing the data. Recommender systems. Recommender systems leverage randomized SVD for predicting user preferences based on their past interactions with items. The low-rank approximation from SVD helps discover latent factors and similarities between users and items, leading to more accurate recommendations. 2. Recommender systems. Randomized SVD is commonly used in recommender systems to predict user preferences based on past interactions with items. The low-rank approximation from SVD helps capture latent factors and similarities between users and items. Image and text processing. In image and text processing, randomized SVD finds applications in tasks like feature extraction, noise reduction, and dimensionality reduction. By identifying patterns and relationships within the data, SVD contributes to tasks such as image compression, text summarization, and topic modeling. 3. Image and text processing. Randomized SVD can be applied to image and text data for tasks like feature extraction, noise reduction, and dimensionality reduction. The SVD helps to identify patterns and relationships within the data. Randomized SVD provides a versatile solution for SVD-based analysis and offers both full SVD and efficient randomized approximations. It is widely used in various machine learning and data science applications. The scikit-learn randomized SVD function is a versatile tool for performing singular value decomposition. It provides both full SVD and efficient randomized approximations, making it suitable for a wide range of applications in machine learning and data science. What is the purpose of the sklearn, utils, xmart, fastlogday function? A. Computes the determinant of a matrix efficiently. B. Calculates the log determinant of a matrix using a faster algorithm than traditional methods. C. Performs matrix inversion. D. All of the above. A. Computes the determinant of a matrix efficiently, while the determinant is related to the log determinant. Fastlogday does not primarily aim to compute the determinant itself. It focuses on the logarithm of the determinant, which is often more stable for numerical calculations. Log determinant. B. Calculates the log determinant of a matrix using a faster algorithm than traditional methods. This is the correct answer. The fastlogday function efficiently computes the logarithm of the determinant, which is useful for many machine learning and statistical tasks. Log determinant. C. Performs matrix inversion. Matrix inversion is a separate operation and not directly related to the function of fastlogday. Determinant. D. All of the above. This is incorrect. The function does not compute the determinant or perform matrix inversion. Its primary purpose is to efficiently compute the log determinant. Log determinant. B. Calculates the log determinant of a matrix using a faster algorithm than traditional methods. Log determinant. The logarithm of the determinant of a matrix. It is often used in statistical modeling and machine learning applications to avoid numerical instability when dealing with large determinants. In Gaussian mixture models (GMMs), calculating the log likelihood involves the log determinant of covariance matrices. It also plays a role in Bayesian linear regression and principal component analysis (PCA). Let's say we have a 2 by 2 covariance matrix. 1, 0.5, 0.5, 1. The determinant of this matrix is 0.75. The log determinant would be log 0.75, which is approximately minus 0.2877. Determinant. A scalar value that represents the scaling factor of a matrix. It is used in various mathematical and scientific applications. Determinants are used in solving systems of linear equations, calculating eigenvalues and eigenvectors, and finding inverses of matrices. For a 2 by 2 matrix A, B, C, D, the determinant is calculated as AD, BC. For example, the determinant of 2, 1, 3, 4 is 2, 4, 1, 3, 5. Covariance matrix. A matrix that describes the relationships between different variables in a dataset. It is used in many statistical and machine learning models. Covariance matrices are used to measure the variability of variables and their relationships, which are crucial in statistical analysis, machine learning, and data visualization. Consider two variables, x and y, with observations x1, 2, 3 and y4, 5, 6. The covariance matrix would be 1, 1, 1, 1. The diagonal elements represent the variance of each variable, while the off-diagonal elements represent the covariance between x and y. Gaussian mixture models GMMs. A probabilistic model that assumes data is generated from a mixture of Gaussian distributions. It is widely used in clustering, density estimation, and anomaly detection. GMMs are commonly used in tasks like image segmentation, speech recognition, and customer segmentation. Imagine a dataset of points representing customers. GMMs can model this data as a mixture of different Gaussian distributions, each representing a distinct customer cluster based on their characteristics. What is the primary purpose of the sklearn, utils, xmart, density function in scikit-learn? A. Calculate the mean of a dataset. B. Determine the sparsity of a matrix. C. Perform matrix factorization. D. All of the above. A. Calculate the mean of a dataset. False. The density function doesn't calculate the mean of a dataset. Calculating the mean is a separate operation often performed using NP, mean in NumPy. B. Determine the sparsity of a matrix. True. The density function directly calculates the sparsity of a matrix. It does this by determining the ratio of non-zero elements to the total elements in the matrix. A higher density indicates a less sparse matrix, while a lower density indicates a more sparse matrix. C. Perform matrix factorization. False. While density can be used in scenarios involving matrix factorization, its primary purpose is not matrix factorization itself. Matrix factorization is a separate process often accomplished using techniques like singular value decomposition SVD. D. All of the above. True. The density function is versatile and has applications beyond just calculating sparsity. It's used in conjunction with various matrix operations, dimensionality reduction techniques, and machine learning algorithms. Therefore, it's involved in all the above, including sparsity determination. D. All of the above. Sparse matrices. Sparse matrices are matrices with a high proportion of zero elements. They are common in various domains like natural language processing, computer vision, and recommender systems. Understanding sparsity is crucial for efficient data storage and processing. Data structures. Efficient data structures are essential for working with sparse matrices. These structures optimize storage and computation, reducing memory usage and computational time. Some popular structures include compressed sparse row CSR, compressed sparse column CSC, and dictionary of keys doc. Efficiency. Efficiency is paramount when dealing with sparse data. Using appropriate data structures and algorithms designed for sparse matrices can dramatically improve performance, especially in large-scale datasets. Optimization. Optimization techniques are crucial for handling sparse matrix operations effectively. These techniques aim to reduce computational time and memory usage, making calculations faster and more resource efficient. Matrix operations. Sparse matrices require specialized operations to avoid unnecessary computations with zero elements. Operations like addition, multiplication, and factorization need to be adapted for sparse data to maintain efficiency. Dimensionality reduction. Dimensionality reduction techniques like principal component analysis (PCA) can be adapted for sparse data. These adaptations are crucial for handling high-dimensional sparse datasets and extracting meaningful information while preserving sparsity. Machine learning. Machine learning algorithms often encounter sparse data, especially in text processing and recommender systems. Certain algorithms are inherently well suited for sparse data, including k-nearest neighbors, support vector machines, and collaborative filtering. Feature engineering. Feature engineering techniques are essential for working with sparse data. These techniques involve creating new features from existing sparse data, potentially leading to improved model performance and insights. Natural language processing. Text data, when represented as matrices, often leads to sparse matrices. Understanding the sparsity of text data is essential for optimizing natural language processing (NLP) models and achieving efficiency in tasks like sentiment analysis and document classification. Computer vision. Computer vision applications, particularly in object detection, often result in sparse matrices. These matrices are often sparse due to the limited presence of objects compared to the overall image space. The sparsity concept plays a crucial role in optimizing computer vision algorithms. Data analysis. Understanding the density of a dataset is a key aspect of data analysis. By analyzing the sparsity of data, analysts can gain insights into the underlying structure and characteristics of the dataset, which can inform the selection of appropriate analysis techniques and models. From sklearn, utils, xstmart import density. Import numpy is np. Matrix np. Array 1. 0, 0, 0, 2, 0, 0, 0, 3. Sparsity density matrix. Print fs sparsity density sparsity. The density function calculates the ratio of non-zero elements to the total elements in the matrix. In this example, the matrix has 3 non-zero elements and 9 total elements. The sparsity density is 390.33. Consider a dataset with features and their corresponding weights. What does xstmart weighted mode calculate? A. The most frequent value, ignoring weights. A. The most frequent value, ignoring weights. False. This describes the standard mode calculation, not the weighted mode. Xstmart weighted mode considers the weights assigned to each value. B. The weighted average of all values. B. The weighted average of all values. False. This refers to the weighted average, which is a different calculation than the weighted mode. Weighted average sums the products of values and their weights. then divides by the sum of weights. Xmart, weighted mode focuses on the most frequent value, taking into account the weights. C. The mode of the values, weighted by their corresponding weights. C. The mode of the values, weighted by their corresponding weights. True. This is the accurate description of Xmart, weighted mode. It identifies the most frequent value mode while considering the weights assigned to each value, effectively making some values more influential in determining the mode. D. All of the above. D. All of the above. False. This is incorrect because options A and B describe different calculations than Xmart, weighted mode. C. The most frequent value in a dataset. In the dataset 1, 2, 2, 3, 3, 3, 4, the mode is 3 because it appears the most times 3 times. Numerical values assigned to features, representing their importance or frequency in the dataset. Imagine a survey where responses are weighted based on the number of people they represent. A response with a higher weight would have more influence on the overall result. A function from scikit-learn's Xmart module calculates the weighted mode of an array, takes input arrays for values and their corresponding weights, returns the weighted mode, considering the influence of each value's weight. Suppose we have features 1, 2, 2, 3, 3, 3, 4 and weights 1, 2, 1, 3, 2, 1, 1. Xmart, weighted mode would identify 3 as the weighted mode because it has the highest weighted frequency, considering the weights associated with each value. Data analysis, analyzing data where certain features have varying levels of importance or frequency. In a customer survey, weights could be assigned to responses based on customer demographics, allowing for a more accurate understanding of customer preferences. Machine learning determining the most common class in a classification problem where class labels have associated weights. In a medical diagnosis system, weights could be assigned to different symptoms based on their prevalence and diagnostic significance, helping to determine the most likely diagnosis. Which function from sklearn, utils, sparsefinx is designed to efficiently calculate the mean of a sparse matrix along the specified axis? A. Sparse, CSC matrix, mean. B. Sparse, CSR matrix, mean. C. Mean sparse. D. All of the above. Correct. The sparse, CSC matrix, mean function is designed to calculate the mean of a sparse matrix in the CSC compressed sparse column format along a specified axis. Correct. Similar to sparse, CSC matrix, mean. This function handles mean calculations for sparse matrices in the CSR compressed sparse row format. Correct. The mean sparse function provides a general approach to calculate the mean of sparse matrices without specifying the format. It intelligently handles different sparse matrix formats like CSR or CSC. Correct. Since options A, B, and C are all valid functions for calculating the mean of a sparse matrix, all of the above is the correct answer. D. All of the above. Imagine you have a large dataset with many features, and some of these features are sparse, have lots of zero values. You want to center or scale these features before training a machine learning model. You can use the mean sparse function to efficiently calculate the mean value of each sparse feature. and then use it to center or scale the data. When working with sparse datasets, you might want to create new features based on existing sparse features. For instance, you could calculate the mean value of a set of sparse features representing the frequency of different words in a document. This mean value could be a useful new feature for text classification. After training a machine learning model on a sparse dataset, it's helpful to analyze the data distribution to gain insights into the model's performance. You can use functions like meansparse to calculate the mean values of different features in your sparse dataset. These mean values can reveal patterns and help you understand the model's behavior better. Sparse matrices are a way to efficiently represent data that contains a lot of zeros. Instead of storing all the values, they only store the non-zero values and their locations. This is very useful for saving memory and computational time when dealing with large datasets with many zeros. Scikit-learn's sparseFinks module provides a set of optimized functions specifically designed for working with sparse matrices. These functions offer efficient ways to perform common matrix operations like mean calculations, sums, dot products, and more. CSR is a popular sparse matrix format. It stores the non-zero values in a compressed form, along with the row indices and column indices of each non-zero value. This structure allows for efficient access to specific rows and values. CSC is another common sparse matrix format. It's very similar to CSR, but instead of storing rows in a compressed manner, it stores columns. This format is particularly useful for efficient column operations like matrix multiplication. Calculating the mean value of a dataset is a fundamental operation in data analysis. In the context of sparse matrices, it's important to use efficient methods like those provided by scikit-learn's sparseFinks to accurately and quickly calculate the mean values along rows or columns. What is the purpose of the sklearn, utils, sparseFinks, income-invariance access function in scikit-learn? A. Calculates the mean and variance of a sparse matrix along a specific axis without loading a entire matrix into memory. B. Performs feature scaling on a sparse matrix, ensuring features have a zero mean and unit variance. C. Calculates the mean and variance of a dense matrix along a specific axis using an incremental approach. D. All of the above. Correct. The income-invariance access function is specifically designed to work efficiently with sparse matrices. It calculates the mean and variance without loading the entire matrix into memory, making it suitable for handling large sparse datasets. Correct. While feature scaling is a common pre-processing step, this function's primary focus is on incremental mean and variance calculation. Feature scaling often involves subtracting the mean and dividing by the standard deviation, which are directly related to the mean and variance calculated by this function. Correct. The income-invariance access function can also handle dense matrices. It uses an incremental approach, allowing it to process data in batches or chunks, making it memory efficient for large datasets. Correct. As explained above, all the statements in options A, B, and C accurately describe the functionalities of the income-invariance access function. This function is designed to be versatile, working with both sparse and dense matrices while employing an incremental approach for efficiency. D. All of the above. Sparse matrices. Sparse matrices are data structures that efficiently store matrices with a high proportion of zero elements. They are commonly used in fields like natural language processing and computer vision where data is often sparse. Text data with a large vocabulary. Image data represented as pixel matrices. Network data with many connections. Consider a text document with a vocabulary of 10,000 words. A sparse matrix can represent this data where each row corresponds to a document, and each column represents a word. Most entries in the matrix would be 0, indicating the absence of a specific word in a document. Incremental calculation. Incremental calculations are methods that compute results in a step-by-step manner, processing data in batches or chunks. This is often used for memory efficiency in handling large datasets. Processing large datasets that don't fit in memory. Real-time applications where data arrives continuously. Streaming data analysis. Imagine calculating the mean of a dataset with 1,000,000 data points. Instead of loading all data into memory, you can process it in batches of 10,000. Each batch mean is calculated, and then these means are combined to get the overall mean. This is an incremental calculation, and it is highly memory efficient for large datasets. Mean and variance. Mean and variance are fundamental statistical measures. Mean represents the average of a dataset, while variance quantifies the spread or dispersion of data points. Feature normalization in machine learning models. Data analysis and understanding the distribution of variables. Statistical hypothesis testing. Consider a dataset of student exam scores 80, 90, 75, 85, 95. The mean score is 80, 90, 75, 85, 95, 585. The variance is the average squared difference from the mean. Calculating the variance for this example will give you an idea of how much the scores are spread out from the average. Which of the following statements accurately describes the functionality of sklearn, utils, sparse finks, in-place column scale? Scales only the non-zero values in a sparse matrix column-wise. Scales all values in a sparse matrix column-wise, including zeros. Applies a scaling factor to the sparse matrix, preserving the sparsity structure. All of the above. Correct. The in-place column scale function scales only the non-zero elements within each column of a sparse matrix. This preserves the sparse structure, ensuring that zero entries remain as they are. A. Scales only the non-zero values in a sparse matrix column-wise. Correct. The in-place column scale function modifies all values in a sparse matrix column-wise. This includes scaling the zeros, which still contribute to the overall matrix structure. B. Scales all values in a sparse matrix column-wise, including zeros. Correct. The scaling operation in in-place column scale is applied to the entire matrix while maintaining its sparse structure. This means that the zeros are preserved, and only the non-zero elements are scaled. C. Applies a scaling factor to the sparse matrix, preserving the sparsity structure. Correct. All the previous statements accurately describe the behavior of in-place column scale. It scales both non-zero and zero values in a column-wise manner, while preserving the sparse structure of the matrix. D. All of the above. D. All of the above. Sparse matrices are data structures that efficiently store matrices with a large number of zero elements. They utilize specialized formats like CSR compressed sparse row or CSC compressed sparse column to represent only the non-zero entries, saving memory and computational resources. Consider a movie recommendation system. A sparse matrix can represent user movie ratings where most entries are zero because a user hasn't rated most movies. Using a sparse format reduces storage space significantly. Feature scaling is a crucial preprocessing step in machine learning, particularly for algorithms sensitive to feature scales, e.g., k-nearest neighbors. Support vector machines. It ensures that all features contribute equally to the model's learning process. In a machine learning model predicting house prices, features like area and number of bedrooms have vastly different scales. Scaling these features brings them to a similar range, preventing one feature from dominating the learning process. In-place operations modify the original data structure directly, rather than creating a new one. This can be beneficial for memory efficiency, especially when working with large datasets. Imagine processing a large image dataset. Instead of creating a copy of each image for modifications, applying in-place operations directly alters the original image, conserving memory and speeding up the process. 1, 0, 3, 0, 0, 2, 0, 4, 5, 0, 1, 0. 0.5, 0.5, 0, 1.5, 0, 0, 1, 0, 2, 2.5, 0, 0.5, 0. This example demonstrates the application of in-place column scale with a scaling factor of 0.5. It shows how the non-zero elements are scaled, while the zeros remain unchanged, maintaining the sparse structure. Which function in sklearn, utils, sparsefinx is used for in-place row scaling of a sparse array? A. In-place CSRROW scale. B. CSR matrix scale. C. Normalize. D. All of the above. In-place CSRROW scale. The in-place CSRROW scale function in sklearn, utils, sparsefinx is specifically designed for in-place scaling of rows in a sparse array represented in the compressed sparse row CSR format. It efficiently scales each row of the sparse matrix by dividing its elements by the row's norm. True. CSR matrix scale. This function is not designed for in-place scaling. While it operates on CSR matrices, it creates a new scaled matrix instead of modifying the original in place. False. Normalize. Normalize is a more general function that can normalize sparse arrays in various ways. But it doesn't specifically offer in-place row scaling. False. All of the above. Not all the choices perform in-place row scaling. False. A. In-place CSRROW scale. Sparse arrays are essential for handling data with a high proportion of zero values. This is common in text processing, where most words in a document are absent. The CSR format efficiently stores sparse matrices by storing non-zero values in their indices. It's commonly used in scikit-learn for sparse array operations. In-place operations modify existing data structures directly, saving memory by avoiding the creation of new copies. This is crucial for handling large datasets. Row scaling is a preprocessing step that normalizes the values in each row of a sparse array. It helps prevent features with larger values from dominating the learning process. Normalization is a broader concept that involves transforming data to a common scale. It includes techniques like min-max scaling, standardization, and row scaling. Scikit-learn is a powerful Python library for machine learning. It provides various algorithms, tools, and utilities for building and deploying machine learning models. This submodule of scikit-learn contains specialized functions for working with sparse arrays, including operations like scaling, normalization, and matrix multiplication. Preprocessing refers to the initial transformations applied to raw data before feeding it to a machine learning model. It often includes steps like cleaning, normalization, and feature engineering. Machine learning is a field of computer science that allows systems to learn from data and make predictions or decisions without explicit programming. Features are the individual variables or attributes used to represent data instances in a machine learning model. They are the inputs used for prediction. 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 0, 7, 0, 5, 3, 2. Let's consider a sparse array with 3 rows and 5 columns. We want to scale each row by a different factor. The scale factors array will have the scale factors for each row. From sklearn, utils, sparsefinks import in place CSRROW scale. Create a sparse array in CSR format. Sparse array CSR matrix sparse array. In place CSRROW scale sparse array CSR. Scale factors. Print sparse array CSRTO array. 0.2, 0.0, 0.4, 0.0.6. 0, 1.33333333 0.01.66666667 0.0 3.0 0.0 0.0 3.5 0.0. What is the primary function of sklearn, utils, sparsefinks, in place swapro in scikit-learn? When working with sparse matrices, to efficiently find the k nearest neighbors of a given data point in a sparse matrix. To perform dimensionality reduction techniques like PCA or LDA on sparse matrices. To efficiently swap 2 rows within a sparse matrix in place, minimizing memory overhead. To calculate the inverse of a sparse matrix. Leveraging the sparsity structure for computational efficiency. All of the above. False. This function does not relate to nearest neighbor search. Nearest neighbor search is usually handled by separate algorithms and libraries like sklearn, neighbors. False. While PCA and LDA work with sparse matrices, this function is not directly involved in those operations. Dimensionality reduction typically uses other functions within scikit-learn. True. This is the core purpose of in-place swapro. By directly modifying the matrix instead of creating copies, it optimizes memory usage, especially beneficial for large sparse datasets. False. Sparse matrix inversion is a complex task with specialized algorithms. This function focuses solely on row swapping, not inverse calculation. False. Only option C is accurate. This function is not designed for nearest neighbor search, dimensionality reduction, or matrix inversion. C. To efficiently swap 2 rows within a sparse matrix in place, minimizing memory overhead. Sparse matrices are matrices where most of the elements are zero. This structure is common in datasets with many features and relatively few non-zero values. Like user-item interactions or document word matrices. They save memory and computational resources by storing only the non-zero elements. User-item interactions representing user preferences for products in e-commerce, where a user might interact with only a small fraction of available products. Document word matrices representing the frequency of words in a collection of documents, where each document may use a limited subset of the vocabulary. Social networks representing relationships between individuals in a network, where connections are relatively sparse compared to the total number of possible relationships. The SIPI, sparse library in Python provides data structures and functions for efficiently working with sparse matrices. It offers different formats for storing sparse data, like compressed sparse row CSR and compressed sparse column CSC, which optimize memory usage and operations. In-place operations modify the original data structure directly, without creating a separate copy. They are beneficial when dealing with large datasets, as they reduce memory consumption and potentially improve performance. Memory efficiency is crucial when working with large datasets. It involves minimizing the amount of memory required to store and process data. Sparse matrices and in-place operations contribute to this efficiency, especially in scenarios with high sparsity. In scikit-learn sklearn, the function in-place swap column is designed for manipulating sparse data. What is the primary function of this method? This function efficiently changes the order of rows within a sparse matrix without creating a copy. It directly manipulates the elements of a sparse matrix, changing their values in place. The function swaps the positions of two columns within a sparse matrix. It converts a sparse matrix to a dense matrix, making it easier to perform column swaps. This function efficiently changes the order of rows within a sparse matrix without creating a copy. False. The in-place swap column function operates on columns, not rows. It's designed to efficiently swap column positions within a sparse matrix. It does not directly modify the elements of the matrix option B or convert it to a dense matrix. Option D. It directly manipulates the elements of a sparse matrix, changing their values in place. False. While the function works in place option C, its primary goal is not to change element values. It rearranges the columns by swapping their positions. The function swaps the positions of two columns within a sparse matrix. True. This is the correct interpretation of the function's purpose. It efficiently swaps the positions of two columns in a sparse matrix without creating a copy. This is crucial for tasks like feature selection and model optimization. It converts a sparse matrix to a dense matrix, making it easier to perform column swaps. False. The function does not convert the sparse matrix to a dense matrix. It directly operates on the sparse representation for efficiency. C. Sparse matrices are data structures designed to efficiently store and manipulate matrices with a high proportion of zero values. They are commonly used in machine learning for dealing with large datasets where most features have zero values. Sparse matrices are highly effective for representing data where most values are zero. This efficiency is particularly important in machine learning, where datasets can have thousands or even millions of features. The in-place swap column function specifically leverages this sparse representation to optimize operations. In-place operations modify the original data structure directly without creating a new copy. This can be crucial for optimizing memory usage and computation time, especially with large sparse matrices. In-place operations are beneficial when working with large datasets, especially sparse matrices, because they avoid the overhead of creating copies. The in-place swap column function operates in place, directly modifying the sparse matrix without creating a new object, saving memory and computational resources. Column swapping. Swapping the columns of a matrix is a common task in machine learning, particularly when dealing with feature selection and model optimization. It involves rearranging the order of features in a dataset. Column swapping is a crucial operation in machine learning because it allows you to rearrange the order of features. This can be useful for analyzing feature dependencies, selectively excluding features, or presenting data in a specific order to the machine learning model. The in-place swap column function provides a dedicated and optimized method for column swapping in sparse matrices. Scikit-learn. Scikit-learn is a widely used Python library for machine learning. It provides a comprehensive set of tools for data preprocessing, model building, and model evaluation. Scikit-learn is a powerful library for machine learning tasks, including data manipulation. The in-place swap column function is part of scikit-learn's sparse functionality. sklearn, utils, sparsefinks, offering specialized tools for efficiently working with sparse matrices. Use cases 1. Feature selection by rearranging columns. You can easily isolate specific features for analysis or remove irrelevant ones. 2. Model optimization. Swapping columns can alter the order in which features are presented to a machine learning model, potentially improving performance. 3. Data visualization. For clearer visualization, you might want to rearrange columns to group related features together. Column swapping has several practical applications in machine learning feature selection. You can easily identify and isolate relevant features for analysis or model building by rearranging columns. Model optimization. Changing the order of features can impact model performance. Sometimes, a different feature order can lead to improved model accuracy. Data visualization. By grouping related features together through column rearrangement, you can create more meaningful and understandable data visualizations. From sklearn, utils, sparsefinks. Import in-place swap column. Import numpy is np. From cp, sparse import CSR matrix. Create a sparse matrix. Data np. Array 1, 0, 2, 0, 3. Row np. Array 0, 0, 1, 2, 2. Col np. Array 0, 1, 0, 2, 1. Sparse matrix. CSR matrix. Data row. Col. Shape 3, 3. Swap columns 0 and 2. In-place swap column. Sparse matrix. 0, 2. Print sparse matrix. This Python code demonstrates the use of in-place swap column. It creates a sparse matrix using CSR matrix from cp, sparse. The code then swaps columns 0 and 2 of the matrix using the in-place swap column function. Printing the modified matrix shows the result of the column swap. How does the sklearn, utils, sparse mean variance access function work in the context of sparse matrices? A. It calculates the mean and variance of all elements in a sparse matrix. B. It computes the mean and variance along a specific axis row or column of a sparse matrix, efficiently handling non-zero values. C. It calculates the mean and variance of only the non-zero elements in a sparse matrix. D. All of the above. Correct. This is true when you set axis none. The function treats the sparse matrix as a flattened array and calculates the mean and variance of all elements, including zeros. Correct. You can specify axis 0 for column-wise calculations or axis 1 for row-wise calculations. The function efficiently handles non-zero values, which is essential for sparse matrices to avoid unnecessary computations. Correct. This is the default behavior of the function. It focuses on non-zero elements to improve efficiency, especially when working with large sparse matrices. Correct. As all the previous statements are correct, the answer is all of the above. Mean variance access is a versatile function that offers these capabilities. D. All of the above. Sparse matrices. Sparse matrices are matrices where most of the elements are zero. They are efficient for storing and processing data with many zero values. Commonly found in areas like natural language processing and recommender systems. Scikit-learn sklearn. Scikit-learn is a powerful Python library for machine learning. It offers various tools for data preprocessing, model building, and evaluation. Sparse matrix operations. These are operations designed to efficiently handle sparse matrices, taking advantage of their structure to optimize computations. Mean and variance. Mean represents the average value of a dataset, while variance measures the spread or dispersion of data points around the mean. Axis row column. In matrix operations, axis refers to the direction along which an operation is performed. Axis 0 indicates column-wise operations, while axis 1 indicates row-wise operations. Feature scaling. Feature scaling is a preprocessing technique used to normalize or standardize the range of features in a dataset. It helps improve the performance of machine learning models by preventing features with larger magnitudes from dominating others. Data exploration. Data exploration involves analyzing data to gain insights, identify patterns, and understand the relationships between variables. It helps in making informed decisions about data preprocessing and model selection. Consider a sparse matrix representing user ratings for movies. Python. Import numpy as np. From CP, sparse imports CSR matrix. Ratings np. Array 5. 0. 4. 0. 0. 3. 0. 2. 1. 0. 0. 0. Rating sparse CSR matrix ratings. This matrix has many zero values representing unrated movies. Mean variance access can be used to calculate the average rating for each movie column-wise mean and the variance in ratings for each user row-wise variance. Python. From sklearn, utils, sparse import mean variance access. Mean ratings. Variance ratings mean variance axis ratings sparse. Axis 0. Print mean ratings. Mean ratings. Print variance ratings. Variance ratings. The results will provide insights into the popularity of each movie and the diversity in user Preferences. Which of the following statements accurately describe the behavior of scikit-learns? In-place column scale function when applied to a sparse matrix in compressed sparse row CSR format. It scales each column of the CSR matrix by its maximum absolute value. It performs in-place scaling of each column by its mean value. It normalizes each column of the CSR matrix to have a standard deviation of 1 and a mean of 0. It scales each column of the CSR matrix by its standard deviation. Correct. The in-place column scale function scales each column by its maximum absolute value. This effectively ensures that the maximum value in each column becomes 1 after scaling. And all other values are scaled proportionally. Correct. The function also scales each column by its mean value. This can be useful for centering the data, particularly when using algorithms sensitive to feature scaling. Correct. The function additionally performs normalization by scaling each column to have a standard deviation of 1 and a mean of 0. This is a common technique for feature scaling, particularly when using algorithms like k-nearest neighbors or support vector machines. Correct. Finally, the function scales each column by its standard deviation. This scaling method is frequently used in algorithms where the scale of features is important, such as principal component analysis (PCA). All of the above statements are accurate. A matrix where most elements are 0, efficiently stored using formats like CSR compressed sparse row 1, 2, 3, 4, 5, 0, 2, 1, 0, 3, 0, 2, 3, 5. A sparse matrix representation where data is stored in 3 arrays: data, indices, and indptr. Modifying the original matrix directly, without creating a copy. Efficient for memory management. Text processing TF-IDF normalize document term frequencies for fair comparison. This is a sample document. Another document with sample text. This document contains different words. Collaborative filtering improve recommendation systems by scaling user item interactions. Image recognition scale pixel values in sparse image representations. Which of the following options correctly describes the functionalities provided by a sparseFinks fast module in scikit-learn? A. It offers fast algorithms for manipulating sparse matrices in the form of compressed sparse row CSR or compressed sparse column CSC formats. B. It provides functions for converting between different sparse matrix formats, such as COO, CSR, and CSC. C. It includes optimized routines for performing basic linear algebra operations on sparse matrices, like matrix multiplication and solving linear equations. D. All of the above. Correct. The sparseFinks fast module excels in handling sparse matrices stored in CSR or CSC formats. These formats are efficient for storing and manipulating sparse matrices, making them ideal for working with large datasets where most of the elements are 0. A. It offers fast algorithms for manipulating sparse matrices in the form of compressed sparse row CSR or compressed sparse column CSC formats. Correct. The module facilitates conversion between different sparse matrix formats, including COO, CSR, and CSC. This allows you to choose the most suitable format based on your specific computational needs and data characteristics. B. It provides functions for converting between different sparse matrix formats, such as COO, CSR, and CSC. Correct. SparseFinksFast offers optimized routines for performing essential linear algebra operations on sparse matrices, such as matrix multiplication and solving linear equations. These optimized routines leverage the sparse nature of the matrices to achieve significant speedups compared to dense matrix operations. C. It includes optimized routines for performing basic linear algebra operations on sparse matrices, like matrix multiplication and solving linear equations. Correct. All of the above statements accurately describe the functionalities of the SparseFinksFast module. It effectively combines sparse matrix manipulation, format conversion, and optimized linear algebra operations, making it a powerful tool for working with sparse datasets. D. All of the above. D. Sparse matrices are matrices with a large number of zero elements. They are particularly useful for representing data with a high sparsity level, such as recommender systems, natural language processing, and computer vision. LTDIV style quote font size 16px quote GTLTBGTSPARSE matrices LTBGT matrices with a high proportion of zero elements. They are essential for efficiently handling large datasets with sparse data structures. LTDIVGT. The compressed sparse row CSR format is a highly efficient way to store sparse matrices. It represents the non-zero elements row-wise, offering fast row-based operations. LTDIV style quote font size 16px quote GTLTBGT compressed sparse row CSR LTBGT a storage format for sparse matrices where non-zero elements are stored row-wise. LTDIVGT. The compressed sparse column CSC format, similar to CSR, stores non-zero elements column-wise. It's optimized for column-based operations and is often used for matrix vector multiplications. LTDIV style quote font size 16px quote GTLTBGT compressed sparse column CSC LTBGT a storage format for sparse matrices where non-zero elements are stored column-wise. LTDIVGT. The coordinate COO format stores non-zero elements as a list of row, column, value tuples. While straightforward, it can be less efficient for operations compared to CSR or CSC. LTDIV style quote font size 16px quote GTLTBGT coordinates COO format LTBGT a sparse matrix format that stores non-zero elements as a list of row, column, value tuples. LTDIVGT. Linear algebra operations, such as matrix multiplication, solving linear equations, and matrix inversion, are fundamental in various scientific and engineering applications. Optimizing these operations for sparse matrices is crucial for handling large datasets efficiently. LTDIV style quote font size 16px quote GTLTBGT linear algebra operations LTBGT operations like matrix multiplication, solving linear equations, and matrix inversion. LTDIVGT. Recommender systems often use sparse matrices to represent user-item interactions, where most entries are zero indicating no interaction. Efficient operations on these matrices are critical for generating personalized recommendations. LT-div style font size 16px GT LTBGT recommender systems LTBGT LTBRGT sparse matrices represent user-item interactions, and efficient operations are crucial for generating recommendations LTDVGT. In natural language processing (NLP), text data can be represented as sparse matrices. For example, a document term matrix stores the frequency of words in each document. Efficient operations on these matrices are essential for tasks such as topic modeling, document classification, and sentiment analysis. LT-div style font size 16px GT LTBGT natural language processing NLP LTBGT LTBRGT text data often represented as sparse matrices, enabling efficient text analysis and processing. LTDVGT. Sparse matrices can represent image features, such as edge detection or object recognition results. Efficient operations on these sparse representations are valuable for tasks like image segmentation, object tracking, and scene understanding. LT-div style font size 16px GT LTBGT computer vision LTBGT LTBRGT sparse matrices can represent image features, allowing for efficient image processing and analysis. LTDVGT. You have a sparse matrix represented in compressed sparse row CSR format. Your task is to normalize the rows of this matrix so that each row's L1 norm sum of absolute values equals 1. Which function in scikit-learn's sparse-fast module provides the most efficient way to perform this in-place normalization? A. In-place CS row normalizal 2. B. CSRROW normalizal 1. C. In-place CS row normalizal 1. D. All of the above. This function normalizes rows using the L2 norm, which is the square root of the sum of squared elements. This doesn't align with the requirement of normalizing rows to have an L1 norm of 1. Hence, this choice is incorrect. A. In-place CS row normalizal 2. While this function normalizes rows by their L1 norm, it doesn't perform the operation in place. It creates a copy of the matrix and modifies that copy, leading to potential performance issues with large matrices. This choice is incorrect. B. CSRROW normalizal 1. This function is specifically designed for in-place normalization of rows using the L1 norm. It modifies the original CSR matrix directly, making it efficient for large datasets. This is the correct choice. C. In-place CS row normalizal 1. Only in-place CS row normalizal 1 meets the criteria of in-place L1 norm normalization. The other options either use a different norm or don't operate in place. This choice is incorrect. D. All of the above. C. In-place CS row normalizal 1. Sparse matrices are matrices where most of the elements are 0. They are commonly used in fields like natural language processing, computer vision, and machine learning due to their efficiency in storing and processing data with a high number of zeros. This is especially important in large datasets where memory efficiency is crucial. Consider a document term matrix in text processing. If you have a corpus of millions of documents, each containing a relatively small number of unique words, the document term matrix will be sparse as most document word combinations will have 0 counts. Sparse matrices can be used to represent such data efficiently. Sparse matrices. The compressed sparse row CSR format is a way to store sparse matrices efficiently. It represents the matrix using three arrays: row pointers, column indices, and data values. This representation saves memory and allows for fast matrix operations. In collaborative filtering for recommendation systems, a user-item interaction matrix can be sparse as not all users interact with all items. The CSR format can be used to store and process this sparse matrix efficiently. CSR format. The L1 norm of a vector is the sum of the absolute values of its elements. It's a measure of the magnitude or size of the vector. In the context of matrix normalization, the L1 norm of a row is used to ensure that each row sums up to 1. When dealing with image features in computer vision, the L1 norm can be used to normalize feature vectors, making them less sensitive to variations in lighting or contrast. L1 norm. In-place operations modify the original data structure directly, without creating a copy. This is important for efficiency, especially when working with large data structures. It avoids the overhead of copying and manipulating new memory locations. In data preprocessing, it's often desirable to perform in-place transformations on large datasets, such as scaling or normalization. This is critical for performance and resource utilization, particularly when working with datasets that cannot be easily fit into main memory. In-place operations. Which of the following statements is true about the BR in-place CS row normalizer 2 function in scikit-learn's sparseFinks fast module? A. It normalizes rows of a CSR matrix by their L2 norm, modifying the matrix in place. B. It normalizes columns of a CSR matrix by their L2 norm, modifying the matrix in place. C. It normalizes rows of a CSR matrix by their L1 norm, modifying the matrix in place. D. It normalizes columns of a CSR matrix by their L1 norm, modifying the matrix in place. True. The in-place CS row normalizer 2 function normalizes rows of a CSR matrix by their L2 norm. The L2 norm is the square root of the sum of squares of the elements in a row. BRBRTHE in-place part signifies that the function modifies the original CSR matrix directly, rather than creating a new one. False. This statement is incorrect. In-place CS row normalizer 2 function normalizes rows, not columns. Moreover, the function utilizes the L2 norm, not L1 norm, for normalization. False. This statement is incorrect. In-place CS row normalizer 2 function normalizes rows using the L2 norm, not the L1 norm. False. This statement is incorrect. In-place CS row normalizer 2 function normalizes rows, not columns. Moreover, the function utilizes the L2 norm, not L1 norm, for normalization. A. Sparse matrix representations. CSR compressed sparse row. COO coordinate list. CSC compressed sparse column are efficient data structures for storing sparse matrices. Matrices with a large number of zero entries. Consider a 5 by 5 matrix with only 3 non-zero elements. 0, 1, 0, 0, 0, 0, 0, 2, 0, 0, 0, 0, 0, 0, 3, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, CSR representation would store the row indices, column indices, and non-zero values separately. Row indices 0, 1, 2, column indices 1, 2, 4, non-zero values 1, 2, 3. Matrix norms. Matrix norms are a way to measure the size or magnitude of a matrix. L1 norm Manhattan distance and L2 norm Euclidean distance are common norms used for normalization. Consider a vector 2, 3. L1 norm 2, 3, 5. L2 norm SQRT 2232 SQRT 13 3.61. In-place operations. In-place operations directly modify the original data structure, saving memory and potentially improving performance. They are often preferred when dealing with large datasets. In Python, the sort method for lists is an in-place operation. The sorted function creates a new sorted list instead. 1. Data preprocessing normalizing features in sparse datasets for machine learning models, such as in recommender systems. In a movie recommender system, the user item interaction matrix can be sparse. Normalizing the rows of this matrix by the L2 norm can improve the performance of collaborative filtering algorithms. 2. Text processing normalizing document vectors in natural language processing tasks like text classification. In text classification, document vectors can be represented as sparse matrices. Normalizing these vectors by the L2 norm can help in reducing the impact of document length. Variations. 3. Collaborative filtering normalizing user item interaction matrices in recommender systems. In a recommender system, the user item interaction matrix can be sparse. Normalizing the rows or columns of this matrix by the L2 norm can improve the accuracy of recommendation algorithms. Which of the following statements are true about the sklearn utils module? A. It provides utility functions for data preprocessing, model selection, and more. B. It includes functions for handling sparse matrices and data validation. C. It offers functions for working with random numbers and generating datasets. D. All of the above. A. It provides utility functions for data preprocessing, model selection, and more. Correct. The sklearn utils module offers numerous functions for data preprocessing tasks such as checkarray, safe indexing, and checkexe, as well as model selection functions like checkrandom state and shuffle. 1. Data preprocessing. Functions like checkarray and safe indexing ensure your data is in the correct format and handle potential issues like missing values or invalid data types. Data preprocessing. B. It includes functions for handling sparse matrices and data validation. Correct. The sklearn utils module provides functions to handle sparse matrices like CSR matrix, CSC matrix, and QMatrix, and offers validation functions like assert all finite and check consistent length. 3. Sparse matrices. sklearn utils makes it easier to work with sparse matrices, essential for handling large datasets with many zero values. Sparse matrices. C. It offers functions for working with random numbers and generating datasets. Correct. The sklearn utils module provides functions to work with random numbers like random state, and includes dataset generation functions such as make classification and make regression. 5. Random number generation. Functions like random state are essential for controlling randomness and ensuring reproducibility in your machine learning experiments. Random number generation. D. All of the above. Correct. Statements A, B, and C are all true about the sklearn utils module. It provides functions for data preprocessing, handling sparse matrices, model selection, data validation, working with random numbers, and generating datasets. The sklearn utils module is a treasure trove of functions designed to simplify and enhance your machine learning workflow. Here's a breakdown of its key functionalities. sklearn utils. D. All of the above. sklearn utils. The sklearn utils module is a collection of utility functions designed to assist with various tasks in machine learning, from data preprocessing to model selection and more. It simplifies common operations and helps you maintain consistency and reliability in your machine learning projects. Let's say you are building a machine learning model to predict customer churn. You might use the checkarray function to ensure your input data is in a suitable format for the model. The checkRandom state function to control randomness in model training. And the make classification function to create a synthetic dataset to test different models. Data preprocessing, model selection, sparse matrices, data validation, random number generation, dataset generation, data preprocessing. Data preprocessing involves transforming raw data into a format suitable for machine learning models. This might include handling missing values, converting data types, scaling features, or removing irrelevant data. Imagine you have a dataset of house prices with features like square footage, number of bedrooms, and age. You might need to preprocess this data by scaling features like square footage to avoid bias in the model's predictions, handling missing values, converting data types, scaling features, removing irrelevant data. Model selection. Model selection is the process of choosing the best machine learning model for a given task. This involves evaluating different models on the same data and selecting the one that performs best based on specific metrics. Suppose you are trying to classify images of cats and dogs. You could evaluate models like a support vector machine (SVM) and a random forest classifier on a labeled image dataset to determine which model achieves the highest accuracy. Sparse matrices. Sparse matrices are matrices where most elements are zero. They are commonly used in fields like natural language processing and recommender systems to efficiently represent data with many zero values. Consider a recommendation system for movies. You might represent user preferences as a sparse matrix, where rows represent users and columns represent movies. A non-zero entry indicates a user's rating for a specific movie. Natural language processing, recommender systems, data validation. Data validation ensures that the data used in machine learning models is consistent, complete, and free from errors. It helps maintain the accuracy and reliability of model predictions. When building a model to predict credit risk, you might use data validation to ensure that input features like income, credit history, and debt-to-income ratio are within reasonable ranges and consistent with each other. Detecting invalid data points, ensuring consistency between input features. Random number generation. Random number generation is essential for machine learning. particularly for tasks like model initialization, hyperparameter tuning, and cross-validation. It helps introduce randomness and ensure reproducibility in model training and experiments. During model training, you might use random number generation to initialize the weights of a neural network. This helps prevent the model from getting stuck in local optima and improves its ability to find the best solution. Dataset generation. Dataset generation involves creating synthetic datasets with specific properties. This is useful for testing and understanding different machine learning algorithms, particularly when real-world data is limited or expensive to collect. You might use dataset generation to create a synthetic dataset with different levels of noise to evaluate how a model's performance is affected by data quality. What is the primary purpose of sklearn, utils, graph shortest path in scikit-learn? A. To construct the graph from a given dataset using a specified algorithm. B. To calculate the shortest path between two nodes in a graph, represented as an adjacency matrix. C. To determine the shortest path between a source node and all other nodes in a graph represented as an adjacency matrix. D. To visualize the shortest path between two nodes in a graph using various graph plotting libraries. False. This function does not involve constructing graphs from datasets. Graph construction is typically handled by other libraries or functions within scikit-learn, like sklearn, datasets, makeblobs for generating synthetic datasets with graph-like structures. False. While this function deals with graphs represented as adjacency matrices, it calculates the shortest paths from a single source node to all other nodes in the graph, not just between two specific nodes. True. This is the accurate description of the function's purpose. It computes shortest paths from a designated starting node to all other nodes in the graph, utilizing the adjacency matrix representation for this task. False. This function focuses solely on calculating shortest paths. It does not handle visualization. For visualization, you would typically employ libraries like matplotlib or networkx in conjunction with the calculated paths. C. To determine the shortest path between a source node and all other nodes in a graph represented as an adjacency matrix. This choice correctly reflects the primary purpose of sklearn, utils, graph shortest path, which is to calculate shortest paths from a source node to all other nodes within a graph, represented by its adjacency matrix, a data structure representing relationships between objects' nodes through connections edges. Consider a social network where users are nodes and friendships are edges. A graph represents the network's structure. A square matrix representing a graph, where each row column corresponds to a node, and elements indicate the presence or weight of an edge between them. Let's say we have three nodes A, B, C. An adjacency matrix could be 0, 1, 0, 1, 0, 1, 0, 1, 0. This matrix shows that A and B are connected, B and C are connected, and there's no direct connection between A and C. An algorithm for finding the shortest path between two nodes in a graph, often utilizing techniques like Dijkstra's algorithm or a search. Imagine a road network with cities as nodes and roads as edges. Dijkstra's algorithm can determine the shortest route between two cities by calculating the shortest Paths from one city to all others, taking into account distances between them. A scikit-learn utility function for computing the shortest path between a source node and all other nodes in a graph represented as an adjacency matrix. Suppose we have an adjacency matrix representing a network of computers. Using this function, we could find the shortest path from a specific computer source node to all other computers within the network. Practical applications of the concept in various domains. Social network analysis, finding influential individuals or groups within a social network by analyzing shortest paths between users. For example, identifying the shortest path from one user to another in a large social network helps understand how information spreads. Route optimization, finding the shortest and most efficient routes for delivery vehicles or travelers in a transportation network. By calculating the shortest paths between different points on a map, we can optimize delivery routes for efficiency or suggest the fastest route to a destination. Recommendation systems, suggesting items or connections based on shortest paths within a user item graph. For example, a music recommendation system might suggest songs based on the shortest path between the users' listening history and other users who have enjoyed those songs. What is the purpose of the sklearn utils random sample without replacement function? A. To generate random numbers without replacement within a given range. B. To randomly select elements from a population without replacement, ensuring each element is chosen only once. C. To generate random samples with replacement from a given dataset. D. All of the above. A. To generate random numbers without replacement within a given range. This statement describes a different function or method, not random sample without replacement. The function focuses on selecting elements from a set, not generating random numbers. False. B. To randomly select elements from a population without replacement, ensuring each element is chosen only once. This is the correct purpose of random sample without replacement. It's designed to generate random subsets of data where each element is picked only once, avoiding repetition. True. C. To generate random samples with replacement from a given dataset. This describes a different type of sampling, often referred to as sampling with replacement. Random sample without replacement explicitly avoids repetition, making this choice incorrect. False. D. All of the above. Since options A and C are incorrect, this choice is also incorrect. Only option B accurately describes the function's purpose. False. B. To randomly select elements from a population without replacement, ensuring each element is chosen only once. Random sampling, a fundamental technique in statistics and data analysis where data points are selected randomly from a population. This helps ensure the sample is representative of the overall population. Imagine conducting a survey to understand the opinions of students at a university. Using random sampling, you could select a specific number of students randomly from the student database, ensuring that each student has an equal chance of being included in the survey. Without replacement. In sampling without replacement, once an element is selected from the population, it is not put back in. This means that the same element cannot be chosen twice. Let's say you have a bag with 10 marbles, each a different color. If you select 3 marbles without replacement, you can't pick the same marble twice. This ensures that the chosen sample is a unique set. Bootstrapping, a resampling technique where multiple random samples are drawn with replacement from the original dataset to estimate the sampling distribution of a statistic. This helps to assess the variability of the statistic. Suppose you want to estimate the average income of a population based on a sample. Bootstrapping would involve repeatedly drawing random samples with replacement from the original sample and calculating the average income for each sample. The distribution of these average income values provides an indication of the uncertainty in a average income estimate. Cross-validation, a technique used to evaluate the performance of a machine learning model by partitioning the data into multiple folds and using different combinations of folds for training and testing the model. This helps to avoid overfitting and assess the model's ability to generalize to new data. Let's say you are developing a model to predict housing prices. Cross-validation would involve dividing the housing price data into 5 folds. You would then train the model on 4 folds and evaluate its performance on the remaining fold. This process would be repeated 5 times, using a different fold for testing each time. By averaging the performance across these 5 runs, you can get a more reliable estimate of the model's performance. LT font style font size 12px GT, which scikit-learn utility functions can be used to efficiently convert a 1D array into a 2D array with 1 column. LT font GT. LT font style font size 12px GT columnar 1 dar font GT. LT font style font size 12px GT columnar 1 dar font GT. False. Columnar 1 dar is not a valid scikit-learn function. There is no such function to convert 1D to 2D array. B. LT font style font size 12px GT Shapir, Lena, 1 LT font GT. B. LT font style font size 12px GT Shapir, Lena, 1 LT font GT. True. Array Shapir, Lena, 1 effectively transforms the 1D array A into a 2D array with Lena rows and 1 column. C. LT font style font size 12px GT column stacker font GT. C. LT font style font size 12px GT column stacker font GT. True. Column stacker takes a 1D array A and stacks it as a column in a new 2D array. This method efficiently converts 1D to 2D with a single column. D. LT font style font size 12px TG treasure pair, -1, 1 LT font GT. D. LT font style font size 12px TG treasure pair, -1, 1 LT font GT. True. Reshape, -1. 1 effectively reshapes the 1D array A into a 2D array with an inferred number of rows based on the size of A and 1 column. The -1 in the shape argument automatically calculates the correct number of rows to accommodate all elements in the original array. ELT font style font size 12px quotient all of the above LT font GT. ELT font style font size 12px quotient all of the above LT font GT. True. Since options B, C, and D are all valid methods for converting a 1D array into a 2D array with 1 column. A. All of the above is the correct answer. LT font style font size 12px all the options provided achieve the desired outcome of converting a 1D array into a 2D array with a single column. Each method utilizes a different approach for reshaping the data. LT font GT. ELT font style font size 12px all of the above. LT font GT. Array reshaping. LT font style font size 12px altering the shape of an array without changing its data. LT font GT. Reshape. LT font style font size 12px reshapes an array into a new shape. Useful for converting 1D to 2D. LT font GT. RNP. Array 1, 2, 3, 4, 5. Newer NP. Reshape 5, 1. Newer 1, 2, 3, 4, 5. Array shape. LT font style font size 12px another way to reshape arrays. LT font GT. RNP. Array 1, 2, 3, 4, 5. Newer NP. Array shape 5, 1. Newer 1, 2, 3, 4, 5. Column stacking. LT font style font size 12px GT combines 1D arrays into columns of a 2D array. LT font GT. Column stack. LT font style font size 12px GT stacks 1D arrays as columns. LT font GT. R1 NP. Array 1, 2, 3. Arranged by 2 NP. Array 4, 5, 6. Newer NP. Column stacker 1. Arranged by 2. Newer 1, 4, 2, 5, 3, 6. Use cases. The concept of reshaping arrays is crucial for various tasks related to data manipulation and machine learning. Machine learning models. Many machine learning algorithms expect data to be in a specific shape, such as a 2D array. Reshaping data allows you to prepare it for these algorithms. Model. Fit x, y. If x is a 1D array, you need to reshape it to a 2D array before fitting the model. Data preprocessing. During data preprocessing, reshaping is often necessary to prepare data for analysis, feature engineering, or model training. From sklearn, preprocessing imports standard scalar, scalar standard scalar, scaled data scalar, fit transform x. If x is a 1D array, you need to reshape it to a 2D array before applying standard scalar. Data visualization. Reshaping allows you to organize data into the correct shape for plotting with libraries like matplotlib. Import matplotlib. Pyplot as plt plus y. If x and y are 1D arrays, they might need to be reshaped to 2D arrays to satisfy the plot function's requirements. Array manipulation. Reshaping provides flexibility for manipulating arrays in various ways, such as transposing, splitting, or combining them. RNP. Array 1, 2, 3, 4, 5. Transposed ARR arranged by reshape 1, 1, T. By reshaping into a single column and then transposing, you can create a row vector 1D array with a single row. Which of the following options best describes the function minpos in scikit-learn's utils? Arrayfun CS. Module A. A function that finds the minimum value in a numpy array. B. A function that returns the index of the minimum element in a numpy array. C. A function that finds the minimum positive value in a NumPy array. D. All of the above. 1. Finding the minimum value, minpos can locate the smallest value in an array, regardless of its sign, positive or negative. True. The minpos function in scikit-learn's utils, array_CS module, can indeed find the minimum value within a NumPy array, whether it's positive, negative, or 0. This capability aligns with the statement in option A. 2. Identifying the index, it also returns the index of the minimum value within the array. True. In addition to finding the minimum value, minpos also returns the index of that minimum value in the array. This is important for knowing the position of the smallest element. Therefore, option B is also correct. 3. Focusing on positive values when dealing with arrays containing both positive and negative values. Minpos specifically finds the smallest positive value in the array. True. Furthermore, minpos is specifically designed to find the minimum positive value within an array when it contains both positive and negative numbers. This feature is reflected in option C, making it a valid description. The minpos function in scikit-learn's utils, array_CS module, is a versatile tool designed to handle various scenarios involving minimum values within NumPy arrays. True. As demonstrated by the previous explanations, minpos fulfills all the characteristics mentioned in options A, B, and C. Therefore, the most accurate description is D. All of the above. D. All of the above. NumPy arrays. NumPy arrays are fundamental data structures in Python's scientific computing ecosystem. They provide efficient storage and manipulation of numerical data, forming the backbone of many data analysis and machine learning tasks. Scikit-learn. Scikit-learn is a powerful Python library widely used for machine learning. It offers a comprehensive suite of algorithms for classification, regression, clustering, dimensionality reduction, and more. Minpos is one of the utility functions provided by scikit-learn to assist with array manipulation. Utils, array_CS module. This module within scikit-learn contains various utility functions designed to streamline array-related operations. Minpos is a part of this module, offering efficient ways to work with minimum values in NumPy arrays. Minimum value. In the context of arrays, the minimum value refers to the smallest element within the array. This value can be positive, negative, or 0 depending on the content of the array. Index. An index in an array represents the position of an element. It's a numerical value that indicates where an element is located within the array. For instance, in an array of 5 elements, the index of the first element is 0. The second element is 1. And so on. Positive value. A positive value is any number greater than 0. Minpos is specifically designed to find the smallest positive value within an array, focusing on the positive contributions or values. Outliers. Outliers are data points that deviate significantly from the rest of the data. They can be caused by errors in measurement or other factors and can have a disproportionate impact on statistical analysis or model training. Minpos could be used to identify potential outliers in datasets. Feature selection. Feature selection is the process of choosing the most relevant features for a machine learning model. Minpos can be useful in feature selection tasks to identify features that have a small positive contribution to a model's performance. potentially indicating features that might be less important. Optimization algorithms. Optimization algorithms are used to find the best solution to a problem, often by minimizing or maximizing a specific function. Minpos could be employed in optimization algorithms to locate the minimum point or the minimum value within a search space. Image processing. Image processing involves manipulating digital images to extract information or enhance their quality. Minpos could be utilized in image processing to identify minimum intensity values within an image, potentially aiding in tasks such as noise reduction or object segmentation. What is the purpose of sklearn, utils, metadata routing in scikit-learn? It helps in seamlessly integrating custom data types and functionality into scikit-learn pipelines. It provides a way to manage and access metadata associated with datasets and models, making them more informative and reusable. It allows for efficient storage and retrieval of large datasets, enabling faster processing and analysis. All of the above. True. The metadata routing mechanism enables the integration of custom data types into scikit-learn pipelines. This is achieved by defining how metadata is associated with and accessed from these custom data types, allowing them to work seamlessly within the pipeline framework. Custom data types. In image processing, you might have custom image data representations that scikit-learn doesn't inherently understand. Metadata routing allows you to define how scikit-learn interacts with these custom image formats, making them compatible with pipelines for tasks like image classification. True. Metadata routing facilitates the management and access of metadata associated with both datasets and models. This metadata can include information about the data source, pre-processing steps, model parameters, and performance metrics, making it easier to understand, interpret, and reuse these assets. Metadata routing. By storing metadata about a dataset, such as its source and pre-processing steps, you can ensure consistency and reproducibility when working with the data. This metadata can also be used to document and explain the data for better collaboration and understanding. True. While metadata routing doesn't directly handle large dataset storage, it contributes to efficient data management by providing a structured way to associate metadata with datasets. This metadata can be used to optimize storage strategies and access patterns, indirectly contributing to faster processing and analysis. Data reusability. Metadata routing can be used to define how datasets are stored and accessed, such as by specifying the format, location, and compression methods. This information can be used to optimize storage and retrieval, leading to faster data processing. True. The metadata routing mechanism effectively achieves all the stated purposes, making it a valuable tool for enhancing flexibility, reusability, and efficiency in scikit-learn. Scikit-learn pipelines. In a machine learning pipeline, you can use metadata routing to define how custom data transformations are integrated into the pipeline. This allows you to seamlessly combine these transformations with standard scikit-learn estimators, making your pipelines more versatile and adaptable. D. All of the above. What does sklearn, utils, metadata routing, get routing for object do? A. Returns the object's type information, e.g., data frame, ND array. B. determines the appropriate routing for a given object based on its metadata. C. Validates the object's metadata against predefined schemas. D. All of the above. This is correct as get routing for object can identify the object's type, e.g. data frame, ND array. This is crucial for knowing how to process the data effectively. It is mentioned in the diagram under the heading explanation in the first bullet point. 1. Type information get routing for object can indeed identify the object's type, e.g. data frame, ND array. This is crucial for knowing how to process the data effectively. This is also correct. The primary function of get routing for object is to determine the correct routing based on metadata. This routing essentially guides how the object should be processed or transformed, ensuring compatibility and optimal performance. It is mentioned in the diagram under the heading explanation in the second bullet point. 2. Routing determination. Its primary function is to determine the correct routing based on metadata. This routing essentially guides how the object should be processed or transformed, ensuring compatibility and optimal performance. This is also correct. Get routing for object validates metadata against defined schemas to ensure consistency and prevent unexpected errors. This is essential for maintaining data quality in robust operations. It is mentioned in the diagram under the heading explanation in the third bullet point. 3. Metadata validation. This function also validates metadata against defined schemas to ensure consistency and prevent unexpected errors. This is essential for maintaining data quality in robust operations. This choice is correct since get routing for object performs all three functionalities mentioned in the previous choices. It's explicitly mentioned as the answer in the diagram. D. All of the above. D. All of the above. Metadata is information about data, such as type, shape, and column names. It helps us understand the structure and context of our data. For example, in a pandas data frame, metadata describes its columns and their data types. Imagine you have a dataset containing customer information like names, ages, and purchase history. The metadata for this dataset would tell us that the data is stored as a data frame. The names are strings, ages are integers, and purchase history is a list of items. Routing is a set of instructions or rules that guide how data is handled. It tells us how data should be processed, transformed, or used in different parts of a program. Routing can be used to ensure that data is handled correctly based on its characteristics. Let's say you have a machine learning model that requires numerical data as input. If your data includes categorical features, routing would guide the process of converting those features into numerical ones, ensuring compatibility with the model. Schemas are predefined structures that specify the expected format and types of data. They act like templates for data, defining the expected structure and content. For example, a schema for a customer database could define expected fields like name, address, and phone number. A company developing a web application might use a schema to define the structure of user data. This schema would specify the expected fields, e.g., username, email, password, and their data types, e.g., string, string, string. This helps ensure that all user data is formatted consistently and meets the application's requirements. What is the purpose of the metadata routing? process routing function within the sklearn utils module? A. It's used to validate the input data for a scikit-learn estimator. B. It's responsible for determining the appropriate data transformations based on the estimator's metadata. C. It facilitates the communication and sharing of metadata between different scikit-learn objects. D. It defines the order in which the data is passed through the estimator's pipeline. E. All of the above. Correct. The process routing function plays a vital role in validating the input data by ensuring it conforms to the expected data types and shapes specified by the estimator. It uses the estimator's metadata to enforce these constraints, helping maintain data integrity and consistency. Data type validation. Correct. The process routing function, by analyzing the estimator's metadata, guides the selection of appropriate data preprocessing steps. It determines which transformations, such as scaling, encoding, or feature selection, are necessary based on the specific estimator's requirements and the characteristics of the input data. Feature preprocessing. Correct. The process routing function acts as a central hub for metadata exchange within scikit-learn. It ensures that metadata is propagated seamlessly between various objects like estimators, transformers, and pipelines. This consistent flow of metadata allows different components to interact effectively and maintain data consistency. Metadata routing. Incorrect. The process routing function focuses on metadata management, not on defining the order of steps within a pipeline. Pipeline construction and the sequence of operations are managed separately through the pipeline class in scikit-learn. None. Correct. The process routing function is crucial for various aspects of scikit-learn operations, including data validation, preprocessing, and metadata management. It ensures the smooth and efficient flow of information throughout the entire machine learning process. Process routing function. E. All of the above. Metadata routing. The process of managing and exchanging metadata between different components in scikit-learn. Metadata is crucial for ensuring data consistency, type safety, and efficient processing within the scikit-learn ecosystem. Data type validation, ensuring the input data conforms to the expected data types specified by the estimator. Feature preprocessing, facilitating the selection and application of appropriate preprocessing steps based on the estimator's metadata and the characteristics of the input data. Consider an estimator that requires numerical data between 0 and 1. Metadata routing ensures that if the input data has values outside this range, it is scaled accordingly. Metadata. Information associated with data or objects within scikit-learn, such as data type, shape, feature names, and other relevant details. Metadata enables scikit-learn to perform efficient data validation, transformations, and model fitting. Data type validation, identifying the data types of features in the input data. Model training, providing information on the number of features and samples to the estimator. Suppose you have a dataset with features like age, income, and occupation. Metadata would store information like data type int, float, string, shape, number of rows and columns, and feature names. Process routing function handles the routing of metadata based on specific rules defined within scikit-learn estimators. It ensures that metadata is propagated correctly throughout the estimator's life cycle, facilitating seamless data manipulation and model training. Model training and evaluation, ensuring that the appropriate training parameters are utilized based on the estimator's metadata and the training data. Model deployment and inference, guaranteeing that the trained model is used correctly during inference, adhering to the expected input data types, shapes, and other metadata requirements. If an estimator expects data to be standardized mean 0, standard deviation 1, process routing ensures that the input data is transformed accordingly before training. What is the primary purpose of font color 0000FF sklearn? Utils, metadata routing, metadata router font. A. To manage the storage and retrieval of metadata associated with objects like datasets, transformers, or models within scikit-learn. B. To facilitate the automatic routing of metadata based on its type or context, ensuring efficient and consistent handling. C. To provide a framework for inspecting and modifying metadata associated with scikit-learn objects. D. All of the above. Storage and retrieval font color 0000FF metadata router font effectively manages the storage and retrieval of metadata associated with different scikit-learn objects, including datasets, transformers, and models. This ensures consistent access and sharing of critical information. True. Routing based on context. The router facilitates the routing of metadata based on the type of object or the specific context in which it's being accessed. This ensures that relevant metadata is efficiently accessed and utilized in different scenarios. True. Inspection and modification font color 0000FF metadata router font provides a controlled framework for inspecting and modifying metadata associated with scikit-learn objects. This allows for fine-grained control and customization of metadata. True. D. All of the above. True. D. All of the above. Metadata refers to information about data, like feature names, data types, and other descriptive attributes. It plays a vital role in understanding and manipulating datasets. Scikit-learn provides various objects for machine learning tasks, including datasets, transformers, and models. Metadata router interacts with these objects to manage associated metadata. Transformers are scikit-learn objects that transform data into a different representation. Often for better compatibility with specific algorithms, metadata router helps maintain metadata integrity during transformation. Models are trained representations of data relationships used for predictions or classifications. Metadata router helps preserve crucial information about models, including parameters and training details. Contexts refer to specific situations or environments where metadata is used. Metadata router intelligently routes metadata based on context, ensuring efficient access and handling. Preserving feature names when transforming data using a transformer-like font. Color 0000FF1 hot encoder font. Font color 0000FF metadata router font ensures that the original feature names are preserved in a transformed dataset. This is crucial for maintaining data interpretability. In this example, font color 0000FF1 hot encoder font converts categorical features into numerical ones. By preserving feature names, Metadata router ensures that the transformed data can still be easily understood and interpreted in relation to the original features. Tracking model parameters. Font color 0000FF metadata router font can store and retrieve model parameters, enabling efficient analysis and comparison of different model configurations. Metadata router allows you to track model parameters, such as regularization strength or the number of hidden layers in a neural network. This information can be used to compare different model configurations and analyze their performance. Managing dataset properties. Font color 0000FF metadata router font can manage metadata associated with datasets, such as the presence of missing values or categorical features, facilitating efficient data preprocessing. Metadata router enables you to manage information about datasets, such as missing value handling strategies or the distribution of categorical features. This information is valuable for data preprocessing steps, allowing you to address issues related to missing data and categorical features. Imagine a dataset with three features: age, income, and location. You use one hot encoder to encode the location feature, creating new columns for each unique location. Without metadata router, you might lose track of the original feature names and the relationship between the transformed data and the original dataset. However, with metadata router, you can preserve the original feature names, age, income, and location and maintain the relationship between the transformed data and the original dataset, ensuring interpretability and consistency in data analysis. What is the primary purpose of metadata request in scikit-learn? A. To manage data preprocessing steps and store their metadata. B. To enable the automatic handling of missing data based on predefined rules. C. To define and manage the metadata associated with datasets and transformations. D. All of the above. True. Metadata request is designed to manage preprocessing steps and store their metadata. This is a fundamental aspect of its role in maintaining data consistency and streamlining data processing. True. Metadata request enables the automatic handling of missing data by storing and applying predefined rules for imputation. This ensures consistent treatment of missing values throughout the pipeline. True. Metadata request is the core component for defining and managing metadata related to datasets and transformations. This metadata includes information about data types, feature names, and transformation details. True. All the options listed are accurate. Metadata request comprehensively manages preprocessing steps, missing data handling, and metadata associated with datasets and transformations. D. All of the above. Metadata management in scikit-learn using metadata request is crucial for ensuring data consistency, reproducibility, and streamlining data processing. It involves storing information about datasets, transformations, and preprocessing steps. Imagine you have a complex machine learning project involving multiple preprocessing steps, such as feature scaling, encoding categorical variables, and imputation. Metadata request helps you track these steps and apply them consistently to new data, ensuring model performance remains consistent. When sharing your machine learning code with others, metadata request ensures they can reproduce your results by capturing the exact metadata associated with the preprocessing steps you used. Suppose you are working with a dataset containing missing values in a numerical feature. You decide to impute these missing values with the median. Using metadata request, you store the information about this imputation strategy, including the feature name and the median value used. Later, when you need to apply the same imputation to new data, metadata request automatically retrieves and applies these settings, ensuring consistency. Preprocessing and transformation in scikit-learn are essential steps for preparing data for machine learning models. Metadata request plays a vital role in managing and storing metadata associated with these transformations, ensuring consistency and reproducibility. Handling missing data is a common challenge in machine learning. Metadata request provides a structured way to define and store rules for imputation, allowing for automated and consistent treatment of missing values across different stages of a pipeline. Data transformation is often necessary to improve the performance of machine learning models. This can involve tasks like feature scaling, encoding categorical variables, or creating new features. Metadata request helps manage the metadata associated with these transformations, ensuring they are applied consistently to new data. Metadata request offers a wide range of applications in machine learning workflows, enhancing data consistency, streamlining data processing, and promoting reproducibility. Metadata request utilizes data structures like dictionaries and lists to store and retrieve metadata effectively. These structures provide a flexible and organized way to manage complex metadata information. Understanding data types is essential when working with metadata. Metadata request handles various data types, including numerical, categorical, and temporal, ensuring accurate metadata management for diverse datasets. Data preprocessing is a crucial step in machine learning, and metadata request enables consistent and reproducible preprocessing by managing metadata associated with transformations like scaling, imputation, and encoding. Data transformation involves modifying data to improve its suitability for machine learning algorithms. Metadata request helps track and apply these transformations consistently, ensuring accurate data manipulation throughout the pipeline. Missing value imputation is a key aspect of data preprocessing. Metadata request facilitates consistent imputation by storing and retrieving rules for handling missing values, preventing inconsistencies in data preparation. Feature engineering involves creating new features from existing ones to enhance model performance. Metadata request helps manage the metadata associated with feature engineering steps, ensuring they are consistently applied to new data. A machine learning pipeline orchestrates various steps, including data preprocessing, model training, and evaluation. Metadata request plays a crucial role in maintaining data consistency and reproducibility within these pipelines. Model training and evaluation require accurate and consistent data. Metadata request ensures data integrity and reproducibility by managing metadata associated with preprocessing steps and data transformations, leading to reliable model performance. How does sklearn's method mapping enable efficient handling of data transformations in model operations? BRBR font style, font size 14 pxb, choose all that apply. B font. A. Method mapping centralizes the execution of data transformations and model operations within a single framework. eliminating the need for separate code blocks. B. It defines a consistent interface for applying data transformations and model operations to various data types, streamlining code and improving maintainability. C. Method mapping promotes code reusability, allowing developers to apply the same transformation or model operation across different data sources and model types. D. All of the above. Method mapping streamlines operations but doesn't necessarily eliminate separate code blocks for transformations and models. It provides a consistent way to manage and execute them. False. Method mapping defines a consistent interface for applying transformations and operations to various data types. This means you can use the same methods on different types of data without having to write separate code. True. Method mapping promotes code reusability by allowing you to apply the same transformations and operations across different datasets and models. True. Since choices B and C are correct, D is also correct as it encapsulates both. True. D. All of the above. Data transformations. Processes applied to raw data to prepare it for machine learning models. Scaling, normalization, encoding, feature extraction. Model operations. Actions performed on a machine learning model, including training, prediction, evaluation, and hyperparameter tuning. Training, prediction, evaluation, hyperparameter tuning. Code reusability. The ability to reuse code across different projects or parts of a project. Applying the same transformations or operations across different datasets or models. Consistent interface. A uniform way to interact with different components of a system. Simplifying the development process. Uniform way to apply transformations and operations regardless of data type or model. Imagine you are building a machine learning pipeline to predict customer churn. You need to perform data pre-processing steps like scaling features and one-hot encoding categorical variables. Method mapping allows you to define these transformations once and apply them consistently across different data subsets, ensuring a standardized approach to data preparation. Let's say you have a dataset with features like customer age, income, and whether they have a subscription. You can use method mapping to define a pipeline that scales the age and income features in one hot. Encodes the subscription feature. Python. From sklearn, utils import metadata routing. From sklearn, preprocessing import standard scalar. From sklearn, linear model import logistic regression. From sklearn, pipeline import pipeline. From sklearn, datasets import load iris. Data load iris. X data, data, Y data, target, pipeline scalar, standard scalar, model, logistic regression, pipeline, fitx, Y, metadata routing, method mapping backend sklearn, def predict self, X, return self, original wrapper, predictix, pipeline, predictix. Method mapping makes it easy to apply these transformations consistently across different datasets, or even different models without having to rewrite the preprocessing steps every time. Which of the following scikit-learn utilities is most commonly used to split data into training and testing sets? A. Train test split. B. Crosswalk score. C. Grid search CV. D. All of the above. True. This is the primary function in scikit-learn for splitting data into training and testing sets. It is crucial for building and evaluating machine learning models effectively. False. This function is used for model evaluation, specifically cross-validation, where the data is divided into multiple folds, and the model is trained and tested on different combinations of folds. False. This is used for hyperparameter tuning. It systematically searches through a predefined grid of hyperparameter values to find the optimal combination for a given model. False. While all of these functions are part of the scikit-learn ecosystem, train-test-split is the primary tool for splitting data into training and testing sets. A. Train-test-split. Data splitting. Dividing data into training and testing sets is crucial for building and evaluating machine learning models. The training set is used to train the model, while the testing set is used to evaluate the model's performance on unseen data. Model evaluation. Assessing the performance of a machine learning model is essential to understand its effectiveness. Common evaluation metrics include accuracy, precision, recall, and F1 score. Hyperparameter tuning. Optimizing the hyperparameters of a machine learning model involves finding the best combination of settings for the model's architecture and learning process. This can be achieved through methods like grid search, random search, or Bayesian optimization. Cross-validation. Cross-validation is a technique used for evaluating the performance of a model by splitting data into multiple folds. The model is trained on different subsets of the data and tested on the remaining fold, providing a more robust evaluation of its performance. Grid search. Grid search is a method for hyperparameter tuning that systematically evaluates the performance of a model with different combinations of hyperparameter values. It involves creating a grid of parameter values and training the model with each combination. Pipeline. A pipeline in machine learning is a sequence of data transformations and model training steps. It allows for organizing and automating machine learning workflows. Training and testing. Using train-test-split, you can create a training dataset to train your machine learning model and a separate testing dataset to evaluate its performance on unseen data. This ensures that your model is not overfitting to the training data and can generalize well to new data. Model selection. You can use cross-val score to evaluate different models on multiple folds of your data. This provides a more robust comparison of the model's performance and allows you to choose the model that is most likely to generalize well to new data. Hyperparameter optimization. Utilize tools like grid search CV to systematically search for the optimal set of hyperparameters for your chosen model. This involves defining a grid of parameter values and training the model with each combination, allowing you to find the best combination for your specific task. What is the primary function of the estimators utility within scikit-learn? A. Provides a comprehensive list of all available estimators in scikit-learn. B. Performs cross-validation on a dataset using all estimators. C. Evaluates the performance of various estimators on a specific dataset. D. All of the above. True. The estimators utility provides a comprehensive list of all available estimators within scikit-learn. This includes a wide range of algorithms for classification, regression, clustering, dimensionality reduction, and model selection. Estimators in scikit-learn. True. The estimators utility enables you to perform cross-validation on a dataset using all estimators. This functionality allows you to systematically assess the performance of different models on your data, helping you identify the best performing estimator. Cross-validation techniques. True. The estimators utility can evaluate the performance of various estimators on a specific dataset. It facilitates the comparison of different models based on their ability to generalize to new data, providing insights into which models are most suited for your particular problem. Model evaluation metrics. True. The estimators utility encompasses all of the aforementioned functionalities. It is a powerful tool for exploring the landscape of scikit-learn estimators, conducting comprehensive model evaluations, and identifying the optimal model for your data. Model selection in machine learning. D. All of the above. Let's say we have a dataset with features representing customer attributes in the target variable, indicating whether a customer will purchase a particular product. We can use estimators to explore various classification algorithms, e.g., logistic regression, decision tree, support vector machine, and perform cross-validation to assess their performance on this dataset. Based on the evaluation metrics, we can then choose the most suitable model for predicting customer purchase behavior. Estimators are the core building blocks of machine learning models in scikit-learn. They are classes that represent specific algorithms for tasks such as classification, regression, clustering, and dimensionality reduction. Each estimator has its own set of parameters that can be adjusted to tune its performance. Logistic regression, decision tree, support vector machine, random forest, naive Bayes. Linear regression, ridge regression, lasso regression, random forest regressor. K-means clustering, DBSCAN, hierarchical clustering. Cross-validation is a crucial technique for evaluating the generalization performance of machine learning models. It involves dividing the dataset into multiple folds and using different subsets for training and testing the model. This helps to reduce the risk of overfitting and provides a more robust estimate of the model's performance. K-fold cross-validation. Stratified K-fold cross-validation, leave one out cross-validation. Model evaluation metrics are used to quantify the performance of machine learning models. They provide insights into how well a model is performing on the given task and help us compare different models. Choosing appropriate metrics depends on the specific problem and the desired outcomes. Accuracy, precision, recall, F1 score, AUCROC. Mean squared error MSE, root mean squared error RMSE, R squared R2. Model selection involves choosing the most appropriate machine learning model for a given problem. This process involves considering factors such as the nature of the data, the desired outcomes, and the computational resources available. It often involves comparing the performance of different models using cross-validation and evaluation metrics, hyperparameter tuning, feature engineering, ensemble methods. What is the purpose of sklearn, utils, all displays in scikit-learn? A. Discover all available visualizations within scikit-learn. B. Generate a list of all metrics, including classification, regression, and clustering, used in scikit-learn. C. Show all pre-processing techniques and feature extraction methods available in scikit-learn. D. List all the datasets available for use with scikit-learn. E. All of the above. This option is correct as sklearn, utils, all displays lists down all the available visualizations. Within scikit-learn, visualizations, discover all available displays. If you want to explore the visualization options provided by scikit-learn for analyzing and presenting your machine learning model results, you can use sklearn, utils, all displays to list down all the available visualizations. This will help you select the most suitable visualization tool for your needs. Whether you want to create scatter plots, histograms, heat maps, or other types of visualizations, this option is correct as sklearn, utils, all displays lists down all the metrics used in scikit-learn. Metrics. When evaluating the performance of your machine learning models, you need to choose appropriate metrics based on your specific problem and objectives. For example, if you are building a classification model, you might use metrics like accuracy, precision, recall, or F1 score. sklearn, utils, all displays provides a comprehensive list of all available metrics in scikit-learn, allowing you to explore and select the most suitable metrics for your model evaluation. This option is correct as sklearn, utils, all displays lists down all the pre-processing and feature extraction methods available in scikit-learn. Pre-processing. Before training a machine learning model, it's crucial to pre-process and transform your data to improve its quality and make it more suitable for model training. sklearn, utils, all displays provides information on all the available pre-processing techniques and feature extraction methods within scikit-learn. This can help you choose the most effective methods for your specific data preparation needs, such as scaling, encoding, or feature selection. This option is correct as sklearn, utils, all displays lists down all the datasets available in scikit-learn. Datasets. Scikit-learn comes with a variety of built-in datasets that you can use for experimenting with different machine learning algorithms and techniques. sklearn, utils, all displays provides a list of these datasets, allowing you to explore and choose suitable datasets for your learning and development purposes. These datasets can serve as valuable resources for testing and comparing different models without the need for extensive data collection and preparation. This option is correct as sklearn, utils, all displays all the above options. sklearn, utils, all displays. Discover all available displays. sklearn, utils, all displays is a versatile function that provides comprehensive information about various aspects of scikit-learn. You can use it to quickly discover available visualizations, metrics, pre-processing techniques, feature extraction methods, and datasets. This centralized information makes it convenient for users to explore and utilize the wide range of tools and resources offered by scikit-learn for their machine learning tasks. All of the above. What is the primary function of sklearn, utils, all functions and its importance in working with scikit-learn? Provides a list of all available functions within scikit-learn, aiding in code completion. Organizes scikit-learn functions into categories based on their functionality. Performs automatic parameter tuning for scikit-learn models. All of the above. All of the above. Correct. This is one of the key roles of all functions. It provides a comprehensive list of functions, which can be extremely helpful in code completion features of IDEs or text editors. This list is a valuable resource for exploring and discovering new functions within the library. Provides a list of all available functions within scikit-learn, aiding in code completion. Correct. The output of all functions often presents a categorized list of functions, making it easier to navigate and understand the organization of scikit-learn. It helps to identify relevant functions based on their purpose, improving the overall efficiency and effectiveness of coding. Organizes scikit-learn functions into categories based on their functionality. Correct. While all functions itself doesn't perform parameter tuning, its output can be a valuable resource for identifying potential parameter tuning methods within scikit-learn. By exposing the functions, it allows you to explore and leverage these techniques for optimizing your models. Performs automatic parameter tuning for scikit-learn models. Correct. All functions fulfills all the above functionalities, providing code completion support, organizing functions, and offering insights into available parameter tuning methods. All of the above. sklearn, utils. A module containing various utilities for working with scikit-learn. All functions. A function that retrieves a list of all available functions within scikit-learn. Code completion. The process of suggesting relevant code as you type, improving efficiency. Function organization. Categorizing functions based on their purpose for better comprehension. Parameter tuning. Optimizing model parameters to achieve better performance. Scikit-learn models. Algorithms for various machine learning tasks, such as classification, regression, clustering, etc. Rapidly exploring scikit-learn's capabilities and finding the right function for your tasks. Understanding the structure and organization of scikit-learn's functions for efficient code development. Assume you have a dataset of customer purchase history with features like age, income, product category, and purchase amount. You are building a machine learning model to predict the probability of a customer making a purchase in the future. Using sklearn, utils, all functions. You could explore all the available classification algorithms in scikit-learn, such as logistic regression, decision tree classifier, or support vector machines. This comprehensive list helps you choose the most suitable model for your specific task. Which of the following methods from the sklearn, utils, estimator checks module is used to ensure that an estimator's fit method raises an appropriate error when an invalid input is passed? A. Checkestimator. B. CheckFit method args. C. Checkestimator tags. D. CheckFit method is not overwritten. E. All of the above. Checkestimator. This method performs a comprehensive suite of tests, including validating whether the fit method raises appropriate errors for invalid inputs. However, it focuses on various aspects beyond just checking the fit method's error handling. So while it contributes to ensuring the fit method's robustness, it's not the most direct test for invalid input handling. False. CheckFit method args. This method specifically checks if the fit method accepts the expected arguments, e.g., x, y, and raises an error when invalid data is provided. Therefore, It directly addresses the question's requirement to ensure appropriate error handling for invalid inputs. True. Check estimator tags. This method verifies the presence of estimator type and other essential tags that help scikit-learn understand the estimator's capabilities. It doesn't directly test error handling or input validation within the fit method. False. Check fit method is not overwritten. This method ensures that the fit method isn't overridden in a way that breaks expected behavior, while it indirectly contributes to ensuring the fit method's robustness. It doesn't directly focus on handling invalid inputs. False. While all the mentioned methods contribute to ensuring the estimator's overall functionality, only checkFit methods directly tests the handling of invalid inputs in the fit method. Therefore, this option is correct as it includes checkFit methods which directly addresses the requirement of the question. True. All of the above. Estimator checks. These are a collection of tests provided within the sklearn utils estimator checks module. They ensure that custom estimators adhere to the principles and conventions of scikit-learn. These checks verify essential aspects like input validation, output correctness, and compatibility with other scikit-learn components. Custom model development. When building custom machine learning models, estimator checks help ensure they meet the expected standards and integrate seamlessly with the scikit-learn ecosystem. Third-party library integration. Estimator checks ensure that models from third-party libraries can be effectively used within scikit-learn pipelines and workflows. Maintenance and evolution. As scikit-learn evolves, estimator checks help maintain backward compatibility and ensure that existing models continue to function as expected. Check estimator. This comprehensive test covers the most critical aspects of an estimator, including fitting, predicting, scoring, etc. It helps ensure that estimators meet the fundamental requirements of scikit-learn. Basic functionality verification. It ensures that the basic functionality of the estimator is intact and working as expected. Initial model validation. When creating new models, this check provides an initial assessment of their correctness and adherence to scikit-learn's conventions. Regression testing. It serves as a regression test to catch potential issues that might arise from code changes or updates. Check fit methods. This method focuses specifically on the fit method, the core method of an estimator. It ensures that the fit method accepts the required arguments X for features and Y for labels and raises an error if invalid data is provided. This is crucial for data integrity and model reliability. Data type validation. It checks that the data provided to the fit method is of the expected type and format. Missing data handling. It ensures that the estimator can handle missing values appropriately. Data range checking. It verifies that the data falls within the expected ranges for the model. Dimensionality checks. It checks for consistency in the number of features and samples. Check estimator tags. This method checks for the presence of essential tags like estimator type that provide information about the estimator's capabilities and characteristics. These tags are crucial for scikit-learn's internal operations and for understanding the estimator's behavior. Estimator classification tags help scikit-learn classify estimators into different categories, e.g., classifier, regressor, parameter tuning. Some tags may provide information about the type of parameters the estimator accepts. Pipeline optimization tags can guide scikit-learn in selecting the appropriate estimators for specific tasks within a pipeline. Model comparison tags can help differentiate between estimators and facilitate meaningful comparisons. CheckFit method is not overwritten. This method ensures that the fit method, which is fundamental to an estimator's training process, is not overridden in a way that would break the expected behavior. This helps maintain consistency and compatibility within the scikit-learn framework. Code integrity. It prevents unintended modifications to the fit method that could disrupt its core functionality. Backward compatibility. It ensures that estimators remain compatible with existing scikit-learn functionalities. Model stability. It contributes to model stability by preventing unexpected changes in the training process. What is the primary purpose of the checkEstimator function in scikit-learn's estimator checks module? A. To ensure that custom estimators adhere to scikit-learn's API conventions and best practices. B. To optimize the performance of custom estimators. C. To automatically generate documentation for custom estimators. D. To validate that custom estimators are compatible with scikit-learn's pipeline functionality. A. To ensure that custom estimators adhere to scikit-learn's API conventions and best practices. Correct. The checkEstimator function verifies that custom estimators comply with scikit-learn's API standards. It tests essential methods like fit, predict, score, etc. to guarantee the estimator's correct behavior and interoperability within the scikit-learn framework. A. To ensure that custom estimators adhere to scikit-learn's API conventions and best practices. B. To optimize the performance of custom estimators. Incorrect checkEstimator focuses on API adherence and doesn't directly optimize estimator performance. Optimizations are usually handled through techniques like hyperparameter tuning or algorithm-specific strategies. B. To optimize the performance of custom estimators. C. To automatically generate documentation for custom estimators. Incorrect documentation generation for custom estimators is not a primary function of checkEstimator. While there may be tools or libraries that help with documentation, this is outside the scope of the checkEstimator function. C. To automatically generate documentation for custom estimators. D. To validate that custom estimators are compatible with scikit-learn's pipeline functionality. Incorrect. While compatibility with pipelines is important, checkEstimator focuses on API compliance, not specifically pipeline compatibility. Ensuring pipeline compatibility might involve additional tests. D. To validate that custom estimators are compatible with scikit-learn's pipeline functionality. A. To ensure that custom estimators adhere to scikit-learn's API conventions and best practices. A. To ensure that custom estimators adhere to scikit-learn's API conventions and best practices. Estimator API conventions. Scikit-learn defines a standard set of methods that all estimators must implement, such as fit, predict, score, and others. This ensures consistency and interoperability. LT font style font size 14 px GT LTB GT estimator API conventions LTB GT LT font GT LTB RGT LT font style font size 12 px GTSCIKIT learn defines a standard set of methods that all estimators must implement, such as fit, predict, score, and others. This ensures consistency and interoperability. LT Font GT. Estimator checks. The estimator checks module provides a suite of tests to verify that custom estimators comply with scikit-learn's API conventions and best practices. LT font style font size 14 px GT LTBGT estimator checks LTBGT LT font GT LTBR GT LT font style font size 12 px The estimator checks module provides a suite of tests to verify that custom estimators comply with scikit-learn's API conventions and best practices. LT Font GT. Custom estimators. User-defined machine learning models that can be used within scikit-learn's framework. LT font style font size 14 px GT LTBGT custom estimators LTBGT LT font GT LTBR GT LT font style font size 12 px GT user-defined machine learning models that can be used within scikit-learn's framework. LT font GT. Pipeline functionality. Scikit-learn's pipelines allow chaining multiple estimators like preprocessing steps and a final model for streamlined data processing and model building. LT font style font size 14 px GT LTBGT pipeline functionality LTBGT LT font GT LTBR GT LT font style font size 12 px GTSCIKIT-learn's pipelines allow chaining multiple estimators like preprocessing steps and a final model for streamlined data processing and model building. LT Font GT. Imagine you've developed a novel machine learning algorithm. Before integrating it into a scikit-learn pipeline or sharing it with the community, you can use checkestimator to ensure it meets the required standards and will work seamlessly within the scikit-learn ecosystem. LT font style font size 16 px GT LTBGT US Casalt BGT LT font GT LTBR GT LT font style font size 14 px Imagine you've developed a novel machine learning algorithm. Before integrating it into a scikit-learn pipeline or sharing it with the community, you can use checkestimator to ensure it meets the required standards and will work seamlessly within the scikit-learn ecosystem. LT Font GT. Let's say you've created a custom estimator for linear regression called myLinearRegression. This estimator should have methods like fit to train the model, predict to make predictions, and score to evaluate the model's performance. Before using it, you can use checkestimator myLinearRegression to verify that these methods are correctly implemented according to scikit-learn's API standards. A. To ensure that custom estimators adhere to scikit-learn's API conventions and best practices. What is the primary function of the parameterize with checks decorator in scikit-learn's estimator checks module? This question is about understanding the role of the parameterize with checks decorator within scikit-learn's estimator checks module. This decorator simplifies the process of testing custom estimators by automatically applying a suite of predefined checks. A. It applies a set of predefined checks to ensure an estimator adheres to scikit-learn's API guidelines and conventions. This statement is partially correct. Parameterize with checks does apply predefined checks, but its functionality goes beyond just API adherence. B. It automatically generates test cases for different estimator configurations. This statement is also partially correct. Parameterize with checks can help generate test cases, but it primarily focuses on verifying the estimator's properties and behavior. C. It provides a convenient way to parameterize estimator initialization with various settings. This statement is incorrect. Parameterize with checks is not directly involved in parameterizing estimator initialization. Parameterizing estimator initialization might be a separate concern. D. All of the above. This statement is correct. Parameterize with checks does all of the things mentioned in choices A, B, and C. It applies predefined checks, helps generate test cases, and can indirectly support parameterization. D. All of the above. As explained in the previous sections, parameterize with checks is a powerful decorator that combines the functionalities of A, B, and C, making it a comprehensive tool for testing estimators. Reducing code duplication, it streamlines your testing process by automating the application of common checks, saving you from writing repetitive test code. By automating common checks, parameterize with checks significantly reduces code duplication in your test suite. Instead of writing repetitive checks for each estimator, you can rely on this decorator to ensure consistency across your codebase. Code coverage, a measure of how much of your code is executed by your tests. Providing insight into the thoroughness of your test suite. Code coverage measures the percentage of your code that is executed by your tests. It provides a valuable metric for assessing the comprehensiveness of your test suite and identifying areas that may not be sufficiently tested. What is the primary role of the sklearn, utils, parallel module? A. Handles parallel processing within scikit-learn estimators. B. Manages parallel data loading for large datasets. C. Performs parallel feature engineering transformations. D. All of the above. Correct. sklearn, utils, parallel provides tools to parallelize tasks within scikit-learn estimators, improving training and prediction efficiency. This is achieved by utilizing multi-core processing or distributed computing. Estimators. Correct. This module assists in parallelizing the data loading process, making it faster to load large datasets, especially from disk or network sources. Data loading. Correct. The module allows for parallelizing feature engineering steps like scaling, one-hot encoding, and other data transformations, leading to speedups in data preprocessing. Feature engineering. Correct. All of the provided options A, B, and C are accurate. sklearn, utils, parallel is designed to enhance performance across various stages of machine learning workflows by leveraging parallel processing. Parallelization. D. All of the above. A technique that divides a task into smaller subtasks that can be executed concurrently on multiple processes or machines. This can significantly reduce the overall execution time, especially for computationally intensive tasks. Training large machine learning models. Processing large datasets for analysis or visualization. Running simulations or scientific computations. Rendering complex graphics or videos. Imagine you want to calculate the sum of a large array of numbers. Instead of adding them one by one, you could divide the array into smaller chunks and assign each chunk to a separate processor. The processes would work in parallel, adding their respective chunks, and then the final results would be combined to get the overall sum. This would be much faster than processing the entire array sequentially on a single processor. Machine learning models in scikit-learn that can learn from data and make predictions. Examples include decision trees, logistic regression, and support vector machines, classifying images or text, predicting customer churn, detecting fraud, recommending products or services, forecasting sales or demand. Let's say you want to build a spam filter. You can train a machine learning model like a logistic regression estimator on a dataset of emails labeled as spam or not spam. Once trained, the model can then predict whether a new email is spam or not based on its content. The process of retrieving data from storage or network sources and making it available for processing. For large datasets, data loading can be a significant bottleneck. Loading image datasets for computer vision tasks. Loading text datasets for natural language processing. Loading financial data for market analysis. Loading sensor data for real-time monitoring. Imagine you have a large dataset of images stored on your hard drive. If you were to load all the images into memory sequentially, it could take a long time, especially if you have limited memory resources. By parallelizing the data loading process, you can load multiple images concurrently, significantly reducing the overall load time. The process of transforming raw data into features that are more informative and suitable for machine learning models. This can involve scaling data, creating new features, or encoding categorical variables. Scaling data to prevent features with larger ranges from dominating the learning process. Creating new features that capture relationships between existing variables. Encoding categorical variables into numerical representations that models can understand. Reducing the dimensionality of data by combining features. Consider a dataset that contains information about customers, including their age, income, and gender. You might want to scale the age and income features to ensure that they have similar ranges. You could also create a new feature that represents the customer's purchasing power by multiplying age and income. This new feature might be more informative for a model trying to predict customer behavior. Quiz: choose the best option which describes the functionality of sklearn. Utils, parallel delayed. A function that parallelizes any function by using multiple threads. B. A function that parallelizes any function by using multiple processes. C. A function that parallelizes any function by using a combination of threads and processes. D. A function that returns a delayed object that can be used to execute the provided function later. E. All of the above. Correct. sklearn, utils, parallel delayed can use threads for parallelization as shown in the diagram. Under key concepts and use cases, threads vs. processes. Threads share the same memory space, allowing for efficient communication. True. Correct. sklearn, utils, parallel delayed can also use processes for parallelization as shown in a diagram. Under key concepts and use cases, threads vs. processes. Processes have their own memory spaces, providing better isolation. True. Correct. sklearn, utils, parallel delayed can use a combination of threads and processes, providing flexibility in choosing the appropriate parallelization approach based on the task's nature. True. Correct. sklearn, utils, parallel delayed can return delayed objects that can be executed later. As mentioned in the diagram under key concepts and use cases, delayed execution. This feature allows for scheduling tasks to be executed at a later time, providing flexibility in managing resources and task execution. True. Correct, as all the above options are correct. Option A is the best answer. True. All of the above. Parallel processing is a technique that involves dividing a task into multiple subtasks that can be executed simultaneously on different processes or cores. This allows for faster completion of tasks that can be broken down. Large-scale image processing or data analysis tasks. Threads share the same memory space, making communication between them efficient but prone to race conditions. Processes have their own separate memory spaces, providing better isolation but requiring mechanisms for inter-process communication (IPC). Threads are often used for I/O-bound tasks, e.g., web server handling multiple requests simultaneously, while processes are suitable for CPU-bound tasks, e.g., scientific simulations. Delayed execution allows for scheduling functions to be executed later, providing flexibility in task management and resource allocation. A task can be delayed to run during off-peak hours to reduce server load. sklearn, utils, parallel delayed provides a way to execute functions in parallel, either using threads or processes, and can also return delayed objects for later execution, speeding up machine learning model training by parallelizing tasks like feature extraction, model fitting, or cross-validation. Assume you have a list of 100 numbers, and you want to calculate the square of each number. Using sklearn, utils, parallel delayed, you can split the list into smaller chunks and parallelize the square calculation using threads or processes, resulting in faster execution compared to sequentially calculating the squares on a single core. What are the primary functionalities and advantages of the sklearn, utils, parallel backend module in the context of machine learning tasks? Provides a straightforward mechanism to parallelize computations across multiple cores or processes, potentially accelerating model training and prediction phases. Offers a flexible interface to employ different parallelization strategies like multi-threading, multiprocessing, or even distributed computing, catering to varying computational needs and resources. Enables seamless integration with popular parallelization libraries like joblib and Dask, fostering compatibility and interoperability across various parallel computing environments. All of the above provides a straightforward mechanism to parallelize computations across multiple cores or processes, potentially accelerating model training and prediction phases. Correct. The sklearn, utils, parallel backend module indeed provides a streamlined way to parallelize computations. By distributing tasks across multiple cores, it can significantly reduce the time needed for both model training and making predictions, leading to improved efficiency and faster results. Offers a flexible interface to employ different parallelization strategies like multi-threading, multiprocessing, or even distributed computing, catering to varying computational needs and resources. Correct. This module allows you to choose from a range of parallelization strategies based on your specific requirements and available resources. You can opt for multi-threading, multiprocessing, or even distributed computing, providing flexibility to optimize performance for different scenarios. enables seamless integration with popular parallelization libraries like joblib and Dask, fostering compatibility and interoperability across various parallel computing environments. Correct. Parallel backend smoothly integrates with libraries like joblib and Dask, making it easy to leverage existing parallelization infrastructure and utilize the strengths of these libraries within your machine learning workflows. This interoperability simplifies the process of parallelizing tasks and ensures a more cohesive development experience. All of the above. Correct. All of the statements in options A, B, and C accurately describe the functionalities and advantages of the sklearn, utils, parallel backend module. Therefore, option D is the correct answer. D. The technique of dividing a complex computational task into smaller, independent subtasks that can be executed concurrently on multiple processes or cores. This helps to accelerate the overall computation time, especially for computationally intensive tasks. Model training in machine learning, especially with large datasets. Data processing and analysis, where calculations are resource-intensive. Scientific simulations and modeling, often requiring complex calculations and significant processing power. Image and video processing, requiring substantial computational resources for tasks like feature extraction and analysis. High-performance computing (HPC) applications, where researchers need to perform large-scale simulations and computations. A method of parallel processing that involves creating multiple processes, each running independently on its own core. This provides a powerful way to fully utilize multi-core processes, enabling significant speedups for CPU-bound tasks. Model training with large datasets, where calculations are CPU-intensive and can benefit from parallel execution. Data analysis and manipulation tasks, where complex computations can be distributed across multiple cores. Simulation and modeling applications, where computations often require a high degree of parallelism. A method of concurrency where multiple threads execute concurrently within a single process, sharing the same memory space. This is particularly well suited for I/O-bound tasks, where processes often spend time waiting for external operations to complete. Reading and processing large datasets, where tasks involve interactions with external resources like files or databases. Web applications, where processes need to handle multiple client requests simultaneously. GUI applications, where threads can handle background tasks without blocking the user interface. Network programming, where threads can be used to handle multiple connections concurrently. A technique that spreads computations across multiple machines or nodes, allowing for significant scalability and the ability to handle massive datasets. This enables parallelization on a larger scale, ideal for resource-intensive tasks and data that exceeds the capacity of a single machine. Training extremely complex models on vast datasets, requiring the collective power of multiple machines. Big data analytics, where computations involve processing massive amounts of data that cannot be handled by a single machine. Scientific research and simulations, where computations can be distributed across clusters or grids for increased performance. Cloud computing platforms, where resources can be easily scaled up or down based on computational demands. A popular Python library specifically designed for parallelization tasks, often used in scikit-learn for efficiently parallelizing computations, especially in model training and cross-validation. Parallelizing model training in scikit-learn, where the training process can be significantly accelerated by distributing computations across multiple cores. Performing cross-validation on large datasets, where the evaluation of different model configurations can benefit from parallelism. Applying pre-processing techniques to large datasets, where operations like feature scaling or encoding can be parallelized for efficiency. A powerful Python library for parallel computing, offering a flexible framework to handle large-scale datasets and computationally intensive tasks. Enables efficient parallel execution on various hardware configurations, from multi-core machines to clusters. Handling extremely large datasets that exceed the memory capacity of a single machine. Enabling distributed data processing and analysis. Performing complex computations on large datasets, where tasks can be distributed across multiple cores or machines for improved performance. Building scalable machine learning pipelines, where data processing and model training can be parallelized for efficiency. Developing distributed data analytics applications, leveraging Dask's capabilities for large-scale data manipulation and analysis. A scikit-learn utility module providing a convenient interface to utilize different parallel computing strategies for optimizing machine learning tasks. Streamlining the process of parallelizing scikit-learn workflows, making it easier to integrate with various parallel computing libraries and strategies. Optimizing model training, cross-validation, and other computationally intensive operations within scikit-learn. Enhancing the efficiency of machine learning pipelines by leveraging parallelism where appropriate. Improving overall performance and reducing execution times. Suppose you have a dataset of 10,000 data points and want to train a machine learning model. If training takes 10 seconds per 100 data points on a single core, how long would it take to train the model on a machine with 4 cores using the parallel backend module? With 4 cores, we can divide the dataset into 4 chunks of 2,500 data points each. Assuming perfect parallelism, each core would take 25 seconds, 2,500 data points, 100 data points per 10 seconds, 10 seconds. Since all cores work simultaneously, the total training time would be 25 seconds, the time for one core, making it 4 times faster compared to using a single core. 10,000 data points, 10 seconds per 100 data points, 1000 seconds. What is the primary purpose of the register parallel backend function in scikit-learn sklearn? To define a custom backend for parallel computation. To automatically optimize the number of parallel jobs. To execute all estimators using parallel computing. All of the above. True. The register parallel backend function allows you to define your own custom parallel processing backend if the built-in ones, e.g., low-key threading, don't meet your needs. This provides flexibility for tasks that require specific hardware or communication protocols. 1. Define custom backends. LT font style font size 12px GT. You can use this function to define your own custom parallel processing backend if the built-in ones, e.g., low-key threading, don't meet your needs. This provides flexibility for tasks that require specific hardware or communication protocols. LT font GT. True. The register parallel backend function can be configured to automatically determine the optimal number of parallel jobs for your system, based on the available resources. 2. Automatic optimization. LT font style font size 12 px the register parallel backend function can be configured to automatically determine the optimal number of parallel jobs for your system, based on the available resources. LT font GT. True. By using register parallel backend, you can enable parallel computation for various estimators in sklearn, significantly speeding up training and prediction processes. 3. Parallel execution. LT font style font size 12 px GTBY. Using register parallel backend, you can enable parallel computation for various estimators in sklearn, significantly speeding up training and prediction processes. LT font GT. True. The register parallel backend function provides all the capabilities listed in the previous choices. The register parallel backend function is a powerful tool in sklearn for managing parallel computation. It allows you to do all of the above, dividing a task into smaller subtasks that can be executed concurrently on multiple processes or cores. This can drastically speed up computation time, especially for computationally intensive tasks. Training complex machine learning models on large datasets. Performing hyperparameter optimization using grid search or random search. Processing images or videos for computer vision tasks. Analyzing large volumes of data for scientific research. Imagine you have a large dataset with 100,000 data points. You want to train a machine learning model on this dataset. By using parallel processing, you can split the dataset into 10 smaller datasets, 10,000 data points each, and train 10 different models concurrently. This can significantly reduce the training time compared to training the single model on the entire dataset. The underlying software or hardware that handles the actual parallel execution. Sklearn offers several built-in backends like Loki multiprocessing and threading multithreading. Using Loki for CPU-bound tasks that can benefit from true parallelism, e.g., training complex models. Using threading for I/O-bound tasks that require less overhead, e.g., data loading or pre-processing. Machine learning models in sklearn, such as linear regression, random forests, and support vector machines, that can be trained and used for predictions. Predicting housing prices using linear regression. Classifying images into different categories using a convolutional neural network. Detecting fraudulent transactions using a decision tree. Recommending products to customers using a collaborative filtering model. A Python library used by sklearn to manage parallel computation. Often leveraging Loki or threading for implementation. Training models with n jobs parameter set to a value greater than 1. Allowing joblib to handle parallel execution. A common parameter found in many sklearn estimators that controls the number of parallel jobs to run -1 means using all available processes. Setting njobs1 in a random forest classifier to utilize all available CPU cores for faster training.